Hi, I'm Chris from Airwindows, and we're doing another live coding stream. So, might as well, I'm deciding whether to jump right into that or show you stuff I'm working on. That's a possibility. Hey, also, in case I need to fire off stream audio, I can put this here so I can get at it. And then if I have to go AFK, I can do that. But I mentioned stuff that I'm working on, and I might as well talk about that a little bit. I've been doing a lot of work on this program. This is the thing that I generate reverb impulses in, and I'm going to show you where I've got with it. You hit this button, and it kind of runs. I've made it so that it draws differently, so that no matter what size hall I choose, it will draw this cloud of effect returns, and the delay returns are basically drawn as dots. The green dots are echo returns, and if they're a brighter green, there are more echoes landing on that spot, because such is the density of the 5x5 reverb matrix that there can be a lot of delay returns out of just this many reverbs. That's what a householder matrix is for. But you might also notice something else up on the top there, which is those red dots, and that's what all the recent developments have been about. So here's what I'm doing with this. Apart from some details, like now I have drawn on the bottom of this, move it so that you can see it better. I worked out sort of dimensions for how I measure some of these things. This is for me relabeling stuff that I already had, but now it just spits out for this size of room. If the slew is more than 11.97 dB, as in larger dB number there for negative means it's even quieter. If the slew for a certain section of audio that I used to test becomes quieter than that, I flag it as green. It counts as quieter high frequencies even before you do filtering, which can happen. You can have different high frequencies based on just the arrangement of the delays. Similarly, if I measure on another section, global LUFS, and that is less than minus 12.24, that counts as making it kind of loud. Oh, and I have fired another one. So let's jump over. So when I measure this particular section out of the reverb result, global LUFS will get louder and louder the more dense the reverb is. And at the very top, there are a couple of divisions I've got set up, which I found were more or less similar across no matter how many seats the hall is. And so I just wrote those down. Like if the max RMS of a particular section of my test audio is louder than minus 12.25, I am flagging that as orange. If it's louder than minus 11, as in the amplitude is going to be like a minus 10 or a minus 9 or even a minus 8, I flag that as red, and those count as the loud sonorous things. I'm doing that over a guitar effect. And lastly, and this is the one where I wonder whether maybe I need to fiddle with it more, but it might be fine. For each of these, and it's slightly different for each one, if I select the tone sweep section and the max RMS out of that is, large. You know something? I am calculating these slightly differently because I'm calculating it as if a minus 12 would be larger. And in fact, technically, a minus 12 is less than minus 11, but whatever. As long as I can label it correctly, it's fine. Hey, Jonathan. Hey, everybody. Quick answer. Erwin, if you take impulse responses of natural input bodies, like take a guitar and take a steel or glass rod and go clock on it, that is a impulse response much like a cabinet response. It will have that coloration. You use it as a reverb and it has that coloration draped across whatever it is that you put in, which is something that you can get guitar pedals to do, in fact. So I called attention to something outside of my measuring these things, where I've got a new capacity for measuring them. My process of working through this stuff started to involve those red markings, which are markings of something that I added to the measurement. So you look at that cloud of stuff, and the blue markings are reversals of whether the echo return is getting louder or quieter. And then the green markings are how many of the echo returns stacked up on that moment. And you look at the green markings, and you might notice that they are not all a solid mass of green. In fact, there are spaces between them sometimes. Not all the time, but there are spaces between them. So what would happen if you went through from, say, the beginning is at this point, this would be 0 samples delay, and then it continues to scan through it to where you get the very first returns. They're more easily seen on the blue, but this is a echo return. And start picking out where the echo returns go. You'll see there's spacings between them. What if you counted the spacings between them all? So like if it's really dense in here, maybe there isn't much spacing between them. Although the thing that caught me out, and I'm telling you on this so that I can tell on myself a little bit, because it took me a while to figure this one out, and I think it's working better now that I have. But this is kind of the development of where my reverb stuff is going, and I'm looking to do a little more work on a reverb idea today on stream. If you counted up all of the spacings between echo returns, well, if there's a solid area of bright green, that probably means there is no space between those. There's no empty space between that. So the spacing between the echo returns is going to be one sample. Because the thing I had forgotten about was all of these are prime numbers being added together. What that means is when you're adding variations of prime numbers together and you're always using a prime number for every, like we're adding together all the combinations of these things that you see here. You'll note that I'm also arranging them differently this time, rather than purely randomizing it, or indeed doing the thing that I did a Blue Sky Skeet about, of finding ways of duplicating certain of the numbers and working out whether that was necessary. I've moved on beyond that to another section where I don't think it's going to be necessary to do that anymore. And in fact, it's not even randomly arranged anymore. This is arranged the way I arranged the original Galactic, because that's gone over pretty well with people. So I tried just going, here's the smallest, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. It's going diagonally. And that is distributing the delay lengths over both of the, because in one direction, for one channel, we read them across this way, and then the other direction, we read them sort of down. And that's the way that I get stereo results out of the same householder matrix. But getting back to those delay returns here, right? So we've got these green dots, and these each represent a delay return. In fact, if it's a bright green dot, it represents a bunch of delay returns stacked on top of each other. Like many different delay returns ended up on that number. Many different combinations of these numbers ended up on that, because when you do a householder matrix, what you're doing is you're taking like, okay, this string of these and 97 on the end, and then this string of these and 127 on the end. Same deal, 251. And then you go through and you do this string 163, 97, this string 163, 127. Every possible permutation of these numbers produces a different total amount of delay. That's how a householder matrix works. And it is indeed generating a kind of impulse response algorithmically. You could take that and turn it into an impulse response and it would work. Although, not necessarily as well, because when you generate an impulse response, often that's a process of building it into a impulse response style reverb. That might be turning things into fast Fourier transformer matrices in order to kind of optimize. It's like it's making an MP3 version of it and applying that. And I don't trust that that sounds as good as using the raw calculations of the delays. Plus, this is an efficient way of calculating delays. You only need to do 25 delays and arrange them in this way, and you get a ginormous sound out of it, which I'll be showing a little bit of later. These red dots up at the top represent the density of how many spacings between delay returns there are. And the output is multiplied by the size of the spacing. So like if you have this is like a spacing of 200 and, let me see, I believe this is 512 by 512 and just squished up into this space. So I'm pretty sure that that's going to be around spacings of 600 or more, either one space of 600 between 2 points or a couple of them. And this is going to be about 100. So the end result is multiplied by 600 and it makes it a brighter shade of red. The other ones are multiplied by how far they are out. So this is, whatever this was, it ends up multiplied by like 100 and it made it a brighter shade of red. But down here, we have more examples of like delay returns that are 3 samples apart, for instance. There'd be lots of those, so 3 ends up having many instances, but then you don't multiply it by much. Rather than multiplying by 600, you multiply by 3. Okay, so that didn't make it that big. And it's a plotting of how often those delay returns showed up, scaled by how big of a delay return it is. That's different than I had before. The question becomes, because this is all a matter of fitness functions in what you might call a genetic algorithm. It's like using the forces of nature to produce the best reverb. I made a point in an earlier stream about how it is like using DEI for good, because it's diversity, equity, and inclusion, except for we're not actually looking for equity because we're trying to find the best one and measuring it in order to determine what will be the best one. But we do need to have maximum diversity in the input section or we'll be missing stuff, we'll be skipping over things. To an extent, my choosing to use prime numbers is not having as much inclusion I am. We are talking about the search for best reverb. In fact, I'm running the program in which I do it, and I'll show you the most recent developments I've come upon. I'm starting this out because we're going to tinker with one of these newer reverbs today, and I'm going to do a little more development on it. So I'm kind of like getting it on video, talking through what I've been through in case anybody needs to like take up the flag and continue to do more reverb going forward. If I can't do it anymore, or if anybody else just wants to be doing it. Droplove is talking about, I don't know anything about Robert Edward Grant's recent discovery on prime numbers. I probably also wouldn't understand my mathematics. Look at what just happened here. On screen, while we watched, the reverb came up with a different example. It's a different size, although not very different. It's 938 seats. We've got a different picture being drawn. It has more heavily repeated numbers here. It's a bright shade of green here, meaning that a bunch of different combinations of these numbers ended up in these spots. But then there's also dark spots where not many numbers showed up. I think the optimum would be a sort of pointillist looking thing where it's a cloudy look with scatterings of these reverb returns, because if you have a big bright spot at one point, that's going to act like a little moment of slapback echo. That's been happening in my reverb generation, and people have sometimes found fault with it or complained about it, maybe thinking that I coded in a slapback echo, but I didn't. That's just how the numbers combined. That's why I'm doing all this work. But you'll also notice this area changed. The big bright spot here that was 600 or so spacing is not there anymore. The other bright spot that was like a 100 space is not there anymore. 600 space between means the way the numbers combined left a big gap between the nearest end results of combining all these numbers. And it combines them in two different ways. It combines them horizontally and also vertically, because that's how I run the left and right reverb returners. But again, you might notice less in the way of those red markings. And that is because this has a more even blending of spacings in here. And up to about a week or so ago, I did not have a method of measuring that at all. And up to 2 days ago, I didn't have a debugged method of measuring it. In fact, I can rerun this so that you can see it cycle through some more things. Let's run this again. Or maybe run 2 of them. Pretty sure the computer can handle that, right? I assume it can handle that. And let's see, maybe we'll pick some different sizes. So 300 seats, 3,000 seats. We're not actually using this. I just want to show you what it does. So if I run the 300 seats, watch this area up here, which I'm assuming we can still see. Let me take a quick look. Looks like it, yep. It's making that sort of scattered look, which is not all of the delay returns, the combined delay returns in every space are exactly the same amount. It bounces around. And a slightly brighter area like this will sound like a bit of a slapback effect. But we also don't have a lot of reinforcing numbers, like the spacings are fairly evenly spaced. And let's run this one beneath, which is much larger. The horizontal stripes will be much finer because it'll be over a larger sustain of the reverb. Oh, I guess it didn't work, did it? Let's reopen it and see whether we can make it go. Maybe it didn't like my 3000. I don't care if it didn't. I'm going to try it again. If that doesn't work, I'll try something else. But no, it doesn't like that, does it? Okay, I'm trying too hard with the 3000 spacing. Let's do a 2000 spacing and see if it likes that any better. Yep. One of the things that's going to happen is as I pick these really large spacings, it is going to end up with a really large reverb sound. But you'll notice these lines, where this is now a delayed line and these are much smaller, this is a larger combination of delays because this is a big enough reverb that it's forced to have many spacings between the echo returns, where this one is so dense that it doesn't have that many spacings between the echo returns. And see, it's found another one. This is roughly, actually there's a small gap between that, as if this is the 0 to 512 and then 1024 and just beyond 1024. I believe if this was the second layer, it would not have that tiny space between them. But since it does, I think I have a longest echo of a little over 1,000 samples. And then we've got these other spacings here. And what I am doing to run a fitness function on all of these possible examples, because what we're doing, you see this number that's changing? This is counting the number of tries that I do. So we've done 32,000 attempted random numbers of tries already. And they're always arranged in this sort of diagonal fashion. And we've now changed the brightnesses of these red spots and made one be like, so 5, it's more than close to 2,000 spacing between a couple of the delay returns, probably at the beginning or towards the end. The idea is, if I can measure this, and rather than simply measure like which end result has the least of these bright spots that count as a bunch of delay returns ended up on the same variable, rather than just magnify least extremely bright spots, can I have the spacing between the echoes be evenly distributed, or rather not evenly distributed? Because think about it, if I have a reverb and all the spacings between the echo returns are like exactly 50 or 100 or 200 or 400, those are all harmonically related. That's going to make a drone. It's going to make a note that shows up in the output. Similarly, like 50, 25, 12, 6. If there's lots of those, what's going to happen is there's going to be a metallic quality where the reverb is ringing. It's ringing like a bell. And I've run into that problem before and had troubles with doing stuff where, like the first K Cathedral, which I can show you, was more metallic than people liked. And I believe I've got this set up so I can literally show you that right now. So, the original Cathedral. People found the reverb return of that to be kind of bright and metallic sounding. It's this sort of high frequency ringing going on. And I did other things to get to where I was trying to get it darker. And I've got other things like, for instance, here's a 4x4 matrix, the original Galactic, which is pretty washy and spacey. So is asking, and the answer to that is no. 600 space between is not meant to be feedback. What happens in a reverb is you generate this cluster of echo returns, and every single echo return gets fed back in as feedback, not just the one on the end that with the 600 space between. That just ends up as one kind of tagging along at the end. No, it's just one of the things that gets put into feedback, but all of these echo returns keep getting fed back into the beginning again, and that sustains it out. Otherwise, you have a gated sound, which I can even demonstrate on some things. But point being, we're now running the program and generating a reverb return, but what is causing the speckling of louder parts, like for example where the cursor is, there's a bright green speckle there, and there's one here, and there's one up here. And the reason that's happening is because the code that says don't let these green spots become too bright, at all costs these must not line up with each other, is fighting with the code that says these delay returns need to not all be the same return. It'll make a note. It'll sound like a frequency. That's the thing. So the thing that I got only the other day was, how do you measure these red dots, right? I am not sure what you mean, Leotrix, by feedback delay networks. All of these things are operating on a householder matrix. A householder matrix is like, we're looking at where it says 1433 and so on. Okay, I think I can select it. Well, perhaps not. It's thinking very hard, you see. It's using up one of my cores doing this. But a householder matrix does every combination of this 5x5. Like starting with this, doing all the combinations, then starting with the 1867, doing all the combinations. It does all the combinations of those things, which is a really large number, like 5 factorial or something. I'm not entirely sure. It's definitely more than 5 times 5. And takes the output. The output is one layer of a cluster of delay returns, far more delay returns than you would have just with 25 echoes, because they all combine. And then you feed that back into the beginning of the matrix again. And that is a feedback topology, but inside the householder matrix, there is not a feedback topology. Also, one interesting detail about that is, particularly if you have a 4x4 matrix, which this is a 5x5, with the 4x4 matrix, what you do is there's a diagonal band down the middle of it where you feed it into the next stage inverted. If you do that and then feed your output directly into the input again at full volume, it will sustain forever without going out of control or doing anything untoward. It's like a magical formula for doing reverb matrices, where if you do that correctly and you feed the output back into the input, you get infinite sustain and nothing goes out of control or makes a musical note or anything, which is not the easiest thing to do. That's the magic of a householder matrix, is you're doing this combination of feeding stuff forwards directly or feeding stuff forwards inverted. With the 5x5, you end up having to do like inverted times 3 and forward times 2 or something like that. I found it somewhere. And then only at the very end, after you've gone through all these and you wind up with a result, which is effectively a whole bunch of reverb returns, you feed that output into the very input again. That's how that works. So householder is what that is. Householder does not tell you which of these are better. Householder is only how you go about doing it, and then you're on your own as far as figuring out what numbers are better. And that's where my work has been over the last couple of years or so, and that's where I've come up with something new in the last couple of days. It has to do with those red dots. I have no idea whether I've ever made a pyramid reverb. It's nice that it's recommending it. I'm certainly doing enough work. Bear in mind also, AI doesn't know anything and is really dumb, so the fact that it's recommending me is not actually a really good endorsement, unfortunately. Hopefully I can do better work so it stops recommending me, because it doesn't know. Anyhow. And I do not know what a pyramid interface even is. So you see the red dots there. And you notice that this tiny dot there is one width. And then some of these look like they're different widths. That's because there are multiple space up, and now we've got it a completely different setting. And now we've got this one dot over here, and then we've got what looks like a little rectangle up in the corner, which I assume you can still see. The meaning of that rectangle is that I have multiple spacings that are closely related, like spacing of 2, 3, 4, 5, 6, and so on. And that I consider to be a good thing. Ideally, you would have an unbroken spacing of all the different possible spacings, without any of them poking out more than the others, so that it would be like a red stripe. A red stripe of completely even darkness, like there wouldn't be additional red bright spots like over here. Instead, it would just be blip. I don't know if it's possible to do that though, but I feel like if you did, that would be maximally avoiding ringing and metallicness and those qualities. I've spent some time working on this spacing concept, and some of the efforts I did along those lines, like metering and using in the fitness function this spacing concept, rather than simply the blue is the reversals of whether it's getting louder or quieter, and green, of course, is just the density at any given point. Early experiments with that gave me results where the blue stuff tended to give me a clearer sense that the room had a physical size and shape. There was this holographic quality where it was like, okay, that's where the walls are. That sounds like a room that has walls. Hey, Grants, good to see you. I hope all is well with you as well. Well, I'm going to do some reverb work today, and I'm explaining at length how reverbs even work, because might as well do that in a video. Maybe somebody will discover that later and be able to make some use of it. These red dots represent spacing between the delay returns, something which I've decided it's probably better if those aren't too regular. Now, there's no way that I can really make sure that it follows a particular pattern, but I can measure them. And since I'm going through, and like this number here shows that I have, in the time that we've been talking about this, evaluated 288,000 possible reverbs, and we're looking at the one best so far. That's why it says score up here. It's keeping track of various calculations based on how dense is this, how many of these echo returns are stacking up on top of each other, and these red dots. Red is arbitrary, it doesn't have to be red. What's the spacing between the echo returns? How evenly spaced is it? And one thing we'll see when we start using that as a form of evaluation, it starts making this cloud be more like a broken up cluster. It has this pointillist quality of it, which is probably to the good, because you don't necessarily want your reverb return to be like a series of tape echoes coming back at you. It's supposed to be a consistent wash, but it can never be a completely featureless wash. There's going to be some churn and detail in the sound as it comes back, but you certainly don't want it to have big, loud dynamic spikes showing up, which would be represented as areas of extremely bright green. So here's where I initially did some work on this and then got it wrong and then fixed it, and I'm going to show you what I got, because we're currently looking at what I got when I tried to fix it. I started measuring these red dots, the spacings between the echo returns on the output, and it's spacings between any echo returns. So any time that it goes completely silent, that counts. Even if it's in the middle of a lot of density or out towards the edges where there's just occasional little echoes still kicking around. I'm trying to measure and optimize for continuous lines of red, hopefully not too bright, implying that not only do particular spacings not predominate, like one really bright spot of red there, for instance, which is what we see, and nothing else anywhere else. It needs to have more possible spacings, and they need to be spread out. That's why this tiny red dot here looks like a cube rather than just a tick mark. It's because that's multiple reverb spacings, 3 or possibly 4, and they're right next to each other. So what I did was I started measuring it using slew between adjacent spacings. I started doing it so that it would go like, okay, spacing of 6, what's the slew between the spacing of 6 and the spacing of 7? Okay, this one had like 30 examples of that and then 20 examples of that. That gives me a slew of 10. And my fitness function, the score, is supposed to be a low score, not a high score. It's trying to get the lowest possible number. It starts at like 9,999,000,000, etc., and goes from there. So I started evaluating on this basis of the slew. I would measure it and go like, well, start at 0 spacing. Then what's the slew between 0 and 1, and 1 and 2, and 2 and 3? And I forgot a thing. I forgot that all of my numbers are prime numbers. In fact, the reason it makes a solid marking is something that I added. I realized that all my numbers were prime numbers, so I was constantly making these 1 pixel spaces between each of the echoes. And so I started drawing out echo and then echo plus 1 and going on from there. And that, because it's a fairly high fidelity screen there, so the 1 pixel is not very large. So I'd forgotten I did that. And so I'd have a even, like this little rectangle here, right at the beginning. That is composed of like large numbers of echo returns, because we're measuring each spacing between this entire cluster of stuff. So large numbers of echo returns for 3 and 5 and 7 and 9 and so on. And then some more like 27 and 29 or whatever. And then over here, like, 117, 119, and so on. And those all would show up. Probably some other ones that are not registering brightly enough to see, and this one looks a little bit dark here. And my calculation was simply going, okay, slew between 7 and 8. Okay, that's a big number. And then slew between 8 and 9. Okay, that's also a big number, because 2, 4, 6, 8, etc. were always 0. Because all of my numbers are odd numbers. And combined together, the end result would always be an odd number. And so I did a whole bunch of work, and I ran the program overnight, and I came up with interesting sounding reverbs, to be sure, and was completely missing the point that my fitness function, where I was trying to evaluate the difference between adjacent slots in the spacing meter. Again, you see that little square, tiny square of red, which is a series of spacings, probably quite a large series of spacings, that are just in a row. If those were all like 100 spacings, 100 instances of that spacing, I wanted to start at the number 100, and then maybe, since it's multiplied, like the next one is 90, and then the next one is 80, and then the next one is 70. So they're changing, but they're not changing by all that much. I wanted to be measuring the slew between them so that if the spacing thing was giving me like 90, 80, 70, 60, which is a nice steady drop-off in how often the spacings were happening, that should give a slew rate of 10, 10, 10, 10, because each of them is 10 different from the previous one. And so it would end up with a level of 40. Instead, what I was getting was slew between 90 and 0, and 80 and 0, and 70 and 0, and so on. And so it was just counting how small all the numbers were in total. And you always end up with a bunch of these, so it wasn't optimizing in the right way. So what I ended up doing was spacing it out. I had to make the for next loop go, okay, slew of this plus this minus 2, and then the next one's this and this minus 2. I just needed to step it in that way. And in so doing, I started making it so that it was actually using in the fitness function whether I had these runs of adjacent sample spacings. And I ran that the previous night and then this night, and I have some results. And I don't know to what extent it is going to, that's under the category Step 2 slew. And what I'm going to be doing is trying to get sounds like this is a real world sound. That is effectively, I think that is Rick Beato in the Abbey Road Chamber. That is the clap. And that's what the Abbey Road Chamber really sounds like, recorded by a real microphone. Whereas this is Cape Plate A, which is earlier before I figured out any of this stuff. And it's a 5x5 matrix, but it is not what I would really want. And then here is a more recent one. Same deal, it's doing the kind of thing, but it is not necessarily my highest performing stuff. And then we've got earlier, I've got examples, for instance, and I've measured these all out with these color codings. This is my most recent version of that. The color codings don't always mean the same thing, but blue always means the LUFS on a particular section is louder, and yellow means the slew on a particular section is brighter, stuff like that. Oh, and Garden is not actually the one I even wanted to look at. That I need to generate more of these because these are 4x4s. The 4x4s sound kind of wonky, honestly. It sounds very unrealistic, so I'm hoping this process will give me better 4x4s as well, because I'd like to have better 4x4s than this. After all, this is the form of householder matrix where you can literally make it be infinite. Yeah, this is pretty much wet signal only. Tiny versions. Very, very, very metallic. So I'd like to do better than this. And I can, but not while using these same things. Here's examples of the different ways I measure it. For instance, here is doing a fitness function based only on how loud all the returns were. So you'd have minimum amount of returns and not care anything about spacing. And it's pretty good at having a fullness, especially in the highs. There's a degree of bloom to it. This is the one that's more like holographic. Different kind of sound. More of a sense of there being an actual room in there where you can hear where the walls are. But then lastly, this is the one that came across as more natural. This is caring about the spacing. And it doesn't bloom as much. But there's this realism to it which is appealing to me. And it's harder to get more sustain out of it, smaller ones. But this is getting me closer to that real-world chamber sound. But this is before I worked out that spacing thing, and before I tried to evaluate it based on whether the spacings were spread out in the way I described. So we've got all this different stuff. In fact, we've got a bunch of old ones which are like extremely primitive or don't have any sustain on them at all. These are all using the same sample audio. It's literally all the same in that way. You can hear they don't necessarily sustain as much as the good versions do. And that's because the reverb delays are not lining up properly with these old versions. Like this one called Millions. Same algorithm, same audio. Literally everything the same except for the combination of sounds. Like the delay lines are the only things that are changing here. So with these, I had to end up with extremely long delays in order to make anything work, in order to make anything sustain. So it kind of sounds sustaining, but it's not really very convincing. And these small ones, like 232 or whatever, it just doesn't sound like there's much reverb sustain here. Oh, and I have closed that by mistake. Let me get it back out. By comparison, here's 238 with the new one. And that ain't even its final form, because we're going to spend today fooling with a 1,538 seat room, which manages to get all of these things correct. And I'm going to make that, or a successor, which is even better, into K-Cosmos. See, if I pick too long of a sustain, you get a big delay between the initial sound and the delay. And then we compare that with something like, I don't know, the original K Cathedral. Again, this is what people consider to be overly metallic, and I can switch ahead to a guitar section. You can kind of head to the edge on there. Or a section with alien kittens. I mean, it's a reverb. You can hear what this does on a even older one, which is still reasonably large. Guitars. Yeah. So you hear delays and stuff in there. Only me has Intro the Matrix. Then if we go back to, say, our cathedral. Come on. There's more fullness to it, and it's a little more distant sounding. Oh, you've already got metallic weird ones, don't worry about it. Then when we go over to here for, say, actually, let's use a similar delay length. It's all the same echoes and things, but I've managed to find a way to make it, I've managed to optimize for various things so that exactly the same 5x5 matrix not only gives me a bloom and sustain in here so that it's a fuller sound, but also, and this is an unfiltered sound, less of a metallic quality in the highs and less of a tendency to like accentuate anything. In fact, it can start to sound like it's just the instrument there. And you only really hear the reverb when the instrument stops. The reverb doesn't get in front of the sound. And again, here's our alien kittens. The blue highlighting means all of the bass of this added up to a loud sound. If I run one of these and the bass doesn't add up to a loud sound, it doesn't have that blue marking. And you'll notice that all of these are winnowed down to 3 markings or more. Which doesn't necessarily mean, like here's 1676 here. I've got them marked when there are 4 because it only shows 3. But this one doesn't have the blue marking. Listen to what it does on Alien Kittens. Because again, this is a long reverb. Red or orange means that when the guitar section happens, it makes loud resonant noises. So there's a lot of sustain. It's a long enough reverb time that there's a lot of echoiness in it. But it's a pretty smooth reverb tail. And again, unfiltered. And there are no all-pass filters in here either. It's worst case scenario for being able to do this and have it be good. Usually people have to use all-passes because they smear stuff out. There's the sweep. The sweep means that sound happened and it didn't get too loud, it didn't resonate. And then this is a version where I didn't get the blue marking because this combined noise is not as loud as it could be. And these are all fitness functions. It is first running the program, doing this, going, okay, do this, give me that. And it's cycling through and continually trying to pick what is the best that it's hit so far to achieve this size of room. And it's generating all of these. Again, here we are with the basic spacings are pretty evenly marked, and then we've got a couple of outliers here, and then way more of the early ones, and this one outlier here. And it's going to try to optimize both for the brightness of the green and the even spacing of the red there. And that's how I do. The examples of what I've produced are all in the code of the previous reverbs that I have made. And again, this has been changing on a daily basis sometimes. I have to remake the program, and I've got this little section of them up here where I've got 15 examples. I just fill the whole screen with these and run as many of them as I can at the same time, because each one is only going to use one core. So I just duplicate them and run them in parallel. And I run them overnight. I have a maximum number of trials I can do. This is at 35, and I can go to about 16 million. I think it's about 16, yeah. I can do about 16 million, and a little ways past 16 million, the program crashes, and I can no longer do anything with it unless I wanted to type stuff out from a screenshot or whatever. It'll freeze. So I made them all stop at 16 million, and so they will go until they can't go any further, and then they stop. Yeah, this is basically just a hacky program. It is ironically all in GDScript. It's a Godot program, and Godot is free, so you can get Godot and use it. It's all hacky and wonky, honestly, but I end up with sets of reverb matrices like these, where there are possible examples that I can use. And these are all the ones where they ended up with a high score on multiple measurements at once. I can make a whole bunch of these, like 15 at a time, and I bring them into the laptop. Generate a program, much like if I was to generate this. Produce a plugin. Do that. On my little SD card, I fire up this audio. This is what all of those things were going into, except for, give me a second, I'm going to move my cable over. I'm going to move my cable over, and then I'm going to run off and get another cup of coffee. But not this very instant. First, I got to plug this sucker in. Okay, here I am again. Here's what's going into all those reverbs. It's this example audio. What you can't hear is it's going hard left and hard right, because I'm also using it to evaluate the stereoness of it. Little guitar bips. Then we've got sort of thumps there. There's the guitar. It's a DI. Well, it's not a DI, it's mic'd, but it's close to a DI. Here's a sweep. And here's Alien Kittens. So this is the example audio that I use. And here's the most recent one that I did in verb tests. And this is the settings that they all have to be set to. Some of those older ones, I'm not convinced that they are, But everything that I've done for months uses this one build of this one plugin. The only thing that I ever change is the delay spacings. And this is always the same. And that's what produces the sounds that I evaluate. This is the most recent one that I did. And I save it to a FLAC, a lossless audio file. And then I go into the main computer and I start measuring it. And here, let me get this visible again. Nobody can pay to get a copy of Into the Matrix. At some point, I'll put it out as open source. We shall see. There's nothing really stopping me from doing that. It would slow me down and be more of a pain in the butt if I had to update it all the time and then explain to people what I changed, because it's not really labeled or anything. And it's all in the service of producing plugins like this, which is the one that I intend to be working on today, which is a giant super huge Mondo reverb, but with a couple of changes. For instance, this filter control is a FIR filter. It's a brick wall filter. And my idea here is to do this, right? And see, I've got regen cranked up more than the examples would be. But if you wanted your deep reverb field to be doing this, you'd set the filter so that it had the brick wall filter. And that's what I don't have in those other examples. You'd pick what filteredness you'd want on the FIR filter. And I got a pre-delay, and I got a regen. I don't know if I can take the regen all the way down. Oh, no, it does. So all that deep reverb stuff we've been hearing, what it sounds like when you just listen to one iteration of it is this. This is one layer of the reverb. And I can deres it. And we can filter it. And we can include dry. It's not so much that I really don't want people to have the tool, it's that it's for my use only, and I'm constantly tinkering with it, and I'm not really treating it as you should use this and then you will make, because you have to know how to use the householder matrix as well. Like, it's only a collection of 5 delay times that produces all of this. Like, here is it, and this is the delay times. And that's just what you get out of it. Or I can space it out with the pre-delay. And now you hear dry, but also that's what the reverb sounds like only once. But then when you have regeneration, it does this. Because a householder matrix lets you feed the output into the input again, just to sort of stretch it out. That's where you get a giant sounding reverb. So that's where regen comes in, is you would care about how long it stretches out. We'll hear that again on the guitar that's about to show up. This is me filtering it differently. And then with lots of regen, it stretches out. And with not much regen, it doesn't. So the things I need to work on today are as follows. This version is what I'm going to try to do going forwards. And I'm going to try to make it do this. I've got two separate 5x5 matrices. One of them, I think, is going to end up being early reflections. And the other one is going to be the reverb tail that regenerates and sustains. So, my idea is to run one layer of this which is not filtered, and then run it through filtered, and then that becomes the infinite sustain. What that means is there's going to be a layer which is this. It's bright, and it doesn't sustain. And then that passes on to a layer that's filtered, and that sustains. And I figure out what to do with that. So that's really the hope, like that's the idea. On that note, it's 12:14, so I get to go and make myself a cup of coffee now. I will also hit the facilities for preparing for a long stretch of tinkering with the code and doing this. And let's see how far we can get with this. This is my idea for a new topology. And if it works, I might even be able to quickly demo it with other delay lengths as well, because this is K-Cosmos. This is a super long delay length, which I might end up even adding an even longer one. But it might not stick to that. Might end up doing more. I don't want it to leave just Alien Kittens on forever, so instead maybe I'll pick something else. Let's run this, perhaps through some nice effect. Like, for example, dubplate 2. Here we are. That should be nice. And I will be right back. I'll leave you with some music, and I'll be right back. Hey there, almost ready making my coffee. I am brewing it now. just in time for the track to be done. And to fade into another one. Yeah, this album is one that I did when I was a kid, pretty much. It's an old thing. As you can see, 16-bit, 44.1K, CD rate. This was back when you couldn't really do much else. And it was not done in a DAW, it was done in an ADAT. The synthesizers you're hearing are Koi K4 and Proteus 1. And I have a Proteus 1 handy, in fact. One of the things I did fairly recently was set up my keyboards and things so that I can do stuff with them. Haven't done that much with them, but I got some use out of them for the soft clock demo. And there's a funny story about that, actually. The making the thing for soft clock, I ended up following that up for the most recent plugin and demoing it, the compressor, BeziComp. And I got one of my haters. Guy's like, that drummer is completely sucks and is playing it all wrong and has bad time. And a couple of people jumped to my defense. I think Grenz jumped in and was like, oh, piss off. Naturally, I don't want people yelling at each other in my comment section, so I was like, no, it's fine. People can feel that way if they want. It's based on the soft clock. And also, it's like an 11.8. And the guy got so embarrassed, he deleted the comment, and so the fan responses that were defending me and my response being like, no, it's fine, whatever, all vanished because the guy's initial hateful comment just went away. And the funny thing was I wasn't even correct. It wasn't an 11.8, it was a 7.8. But still, I bet that's what happened. That on the one hand, people came to my defense rather than backing up the guy who was like, this drummer is terrible. He didn't realize it was just me. And he was probably expecting it to be 4.4 and got mad. Oh no. The server got grief. Can you still get in? I guess I'll see what it looks like when I get in. It is possible to roll back some of those things. I'm not sure whether I'm going to. I guess we'll find out. Next time I have a look at it, I'll see what that looks like. Or we could go and look and see, I suppose. I don't know. It's not meant to be me exerting great control to make sure that the server is good. That's not how that really is supposed to go. I do not have the time or energy to do anything like that. So I guess it becomes a question of seeing whether it turns into H2, T2, or whatever, or not. Oh, you got in? All right, fair enough. Okay, well, I mean, I'm not going to jump to reset anything. I'll have a look and see what went on. I suppose we could do that now. Nothing's really stopping me. But today's a work day, though. I'll have a look at that later. Yeah, this is one reason to like have bases off somewhere else. That's not too easily found. If that even matters. Because, I mean, the bottom line is it doesn't really matter. It is my... Oh, well, I'm not going to roll back anything without talking to the people who were there. Yeah, I might just roll with it. Might just see what it's like. Honestly, the stuff that I was doing in that one bass, the amusing griefing was having it be covered with cows. That was like a funny once, but that was still kind of funny. But if everything is just stupid, it's time to like, well, this is a server for playing on, as long as it still functions. And I grant you it's possible that people could grief it by DNSing it or whatever. As long as it still functions, get a boat, sail off to somewhere, and make another base somewhere else. It's about the playing on it rather than making sure everybody's stuff is protected and good. Because it could be like years before I get back in there. Really? Well, I don't appreciate people griefing other people's stuff, but at the same time, I'm not really there to protect it, so we will do what we will. You can say ironically your bass is fine. Well, not for long, presumably. Somebody hears about that, and the next thing you know, boom. So let's see. So what we're actually about is plugin making and distributing software to people and letting you have tools to make music. Music is less easy to grief. I mean, it's possible to grief it by doing what the guy on YouTube did, which is like, your music sucks and your drumming is crap and it's a complete waste of time and why are you even bothering? And that's grief. Granted, that's grief. So, where are we at? Let's have a look at what I'm looking at here. Cosmos is 2 555 matrices, not just one. I've got one that is starting with A and one that's starting with E, which is going to be the early reflections. So my next question is, can I set this up so that it starts to use both of those? And I got some of this marked up and labeled so I know what it does. This is rather interesting. I'm not quite sure what's going on here. Other than this is all part of the FIR filter. So presumably so is this, unless, no. So this is scaling it, and then this is times equals square root freak. I'm pretty sure this is also part of the FIR filter. I think it's a level correction. I haven't put out this filter, by the way. Oh, Leo tricks you out of luck. I don't program as FFTs. I wouldn't mind doing it. I could probably come up with good ways of doing it, but I don't know how to do that yet. There will probably come a day when I do. If I was able to visualize it, I'd probably be able to code it. So, well, first things first, let's move this to elsewhere, because this is all part of that brickwall FIR filter. And how would I be feeding back this stuff? I won't be wanting to use the feedback because that is actually part of, like, I've got 5 by 5, 5 feedbacks per channel. The reason it says A, B, C, D, E and E, J, O, T, Y is because that's how it works out, having it be left or right. See, it's L and R, and it doesn't go through the matrix the same direction on either channel. It goes through the matrix back sideways on one of the channels. But one of the things I have in mind is, see where it's saying this A, AL, and so on? I'd like to simultaneously run another matrix, but use all the same things. Like it says count AL plus plus. I might not, well, I feel like maybe I wouldn't even need to do L and R versions of these, but it doesn't take all that much to do separate versions per channel, and it's probably making it easier to keep track of. I don't know what joss papers are, so that would probably mean no, because I don't know what joss papers are. And Mathy would definitely lose. Well, Mathy sometimes loses me. Sometimes I can work out what the Mathy is doing. Sometimes it's just using like the language of calculus, which I never learned. I put my effort into stuff like these. Where now I'm going to try to work out where to start. Well, here's a possible way to start. Bezamp here is being altered in this way, but that might be what I want to use for the early reflections instead. So let's see if we can modify this. We'll include the pre-delay, but then modify this so I'm actually doing the earlier reflection instead. And we're getting the early reflection from the very output, where the output would sum together to be the output stereo. We'd be summing the early reflection stuff to get the output that then gets put back into the beginning again. But then we also play the output of the early reflection stuff. So that needs to be here. See where we've got these? There's going to need to be a early reflections L and an early reflections R in here, because we need to produce it at the end of the previous pass out of the early reflection content. And then we hear it direct only once, but then it gets put back into the input again as if it was feedback, but then it gets passed through that FIR filter, and probably gets passed through the FIR filter only once, because I don't think anything is to be gained by brickwalling it more than once. I could be mistaken, though. It could be worth finding out. But so here's our first thing. And we're going to have to blank that before using it. But this is what the output of the early reflection pass, which is not filtered, would be. And then I need to run an entirely separate pass for the filtered stuff. See, the way I'm thinking about this currently is, since I can do this brick wall, I'm wondering whether there will be a spaciousness to the reverb from running a brick-walled filtered signal through the regeneration, but then not refiltering it each time. Or another possibility would be to run a simple averaging each time. And that's a very low-level processing, in the sense of it's not going to take any CPU at all. And let's see. So if I make that, then I can cause the averaging. And that might be all I do for each level of after doing the brick walling on there, because the brick walling is going to do important things as far as the tone of the plugin is concerned. But again, two things that I don't know before trying. One of them is if I brick wall going into the reverb, am I going to have higher frequencies than the brick wall coming out? Because it's doing all of these delays, I might end up with an interesting, like, overtones of some kind, or I might not. It might not be able to produce any frequency content just by combining a million delays. Thing is, I wonder whether maybe it can. And we can kind of hear that to a extent in the demo. There is a snare hit. Here's the demo. So this is what we've got so far. So with no filtering, it sustains like that. With heavy filtering, it's a lot darker, and the question is, as it sustains, does it or should it continue to get darker? And does it or should it continue to be brick-walled in the way that it is? Because what we've got here is the input is going into the filter and the regen absolutely does not. In fact, I'm not sure there's a good way for me to do that. My regen is coming in on 10 different channels. That would need to be changed. So let's poke around a little bit and see where that's happening. Here's the deres on the whole thing. See Bez, and then this decoding is drawing a Bezier curve and it's downsampling it. Here's our input sample L and R for our output. Here's our feedback. We have this thing called feedback sum. I believe what this is doing is I'm making an effort to let you layer lots of loud things on top of each other without overloading the delay. I mean, without overloading the reverb. I am not entirely certain it's working, but that is the thing that I'm trying to do. Also, I see an immediate problem. Or maybe it's an immediate problem. See, if these are loud sounds, but they are all balanced between positive and negative excursions, it'll end up at 0. So that's not what I need. So where am I using this feedback term? You're watching me walk my way through all of this stuff. Regen max, pattern the loop by volume of output. That would be where I would be doing that. I can try stuff out. So regen max minus. Okay, so Fab's feedback sum. Oh, and that's a silly mistake. Feedback sum times equals 0.0. Effectively, that's the same as feedback sum times equals 0. I forgot I don't have a 1 here. In order to have that be falling back steadily, I would actually want it to be 9s. See, if I do this, then it will gradually go down. Of course, that's going to cause it to become very large. And furthermore, see, this is suddenly fooling with other things entirely. These are things I overlooked when I looked at this last. So if I get this wrong and feedback sum becomes way larger than regen max, what will happen is it will blow up and freak out. Because what I want to do is produce regen as, oh, well, hang on a second. No, we've already got that covered. If feedback sum becomes enormous, all that will happen is it will be clamped to 0, so that's fine. And here's the part where I'm getting it wrong. It needs to be absolute values. And we can add these like that, and then just add the fabs. This is going to produce a thing where all of a sudden you can't make loud feedback anymore. But that's more or less what I had in mind. I just was doing it wrong the first time, as one does. So as you can see, oh, well, hang on a second. Scaling it meant nothing. Or no, wait, nope, hang on. That wasn't actually about scaling it so much as it was making sure that it was scaled down enough. It did not matter that, because we started it down here. So every cycle, we're starting with each of these, and the next time we do a feedback, next time we come through, we've got all of those added together. I had forgotten to do the fabs, but that's fine. And then I was wrong about being wrong, because I had made it fabs here anyhow. And then this was not about gradually scaling it each time. This was about scaling it down once, meaning I could just as well take it over to here, and here's where we scale it down to be tiny because we're modulating regen by that. So long as we're doing that, we've now just made these be absolute values. This is going to make it more effective at what it does. I should also blank out the early reflections and things first before we go any further. Let's go to the same place and gotta blank those out. Okay, now I can work with those next time I want to. Maybe we'll even be able to hear what it sounds like when I apply the averaging thing. Because currently we're not applying anything of the sort. Also, I do see a problem in that I actually need more than just that. So maybe this is a fine time to go and look into this. How should we go about doing it? Like this. So some of these were A through E, because I'm applying them to feedback A through E, L, C, D, L, and then some of them are E, R, J, R, OR, TR, and YR. See, they match what feedback says because I've got that many feedback elements to put in. And I'm going to see what it sounds like averaging the feedback with just a single 2-sample average, which could end up at a lower frequency because I do have the deres in there. But this now also means I have to adjust something up here as well. But then I'll be able to try it. You can see I am going to take a roughly similar approach. Oh, that was an R. And then it wants ER, JR, OR, TR, and YR, and those now match the feedback parameters that I'm passing back into the input again. So now when it's time to use those, I can. Technically, I could pass the early reflection stuff through that way as well, but I don't know if I want to go about doing that. In particular, I don't think I do because I want to pass it through that FIR filter. So let's see, where we got? The next thing to find out, oh, hi, why would you say that? Oh, because I spelled it reflection. Haven't even used it and it's giving me trouble. Alrighty. So that's done it with that section, I think. So what we are about to find out is what happens when it is suppressing feedback based on how loud feedback is. And that's a fine example to do with it. We'll pick this section. Because that's going to be real intense. Fire up K-Cosmos. No filtering, no pre-delay, full wet. And how loud does it get now? Yeah, see, this is why that other thing had all of that 0.000001. Now we don't have any sustain because the value that we're passing into the beginning again to subtract from regen, it's so sensitive that it's like not letting the sound even get to be as loud as the raw sound is. It's suppressing it that hard. But there's something we can do to test that out. We've got other parameters available, you see. So get parameter F, for instance. And type in the F. Now if we scale that thing that we're passing through with this multiplication there, if we then multiply it also by that, we can cut it back to 0, at which point it will be full-on sustain. Or we can crank it up all the way, and it'll be suppressed as hard as we were just hearing. And that is done. Let's see, come on. There we are. Feedback sum. There. Now we have that on a slider, and now we include it. We're definitely gonna, it's so extreme, I'm going to give it another 0 just to be sure, because I would have to have it so barely cracked open. Now let's see what we've got. Because the idea, and I should be able to test this out fairly well, is to, if no sound is happening, then it'll continue. But if we're loading it with more sound to the point where it would blow up and be far too loud, it should be able to suppress itself a little bit. Let's see how close we came. And here's a silent section, and then the guitar section. And here's K Cosmos, and here is F at 0. So if I do this, it should give me, is it giving me? Oh, I haven't hit play, that's why. Oh, I hit apply instead of play. There we go. Now I hit play. So it was prepared to work, but I just applied it without listening to what it was doing. So with no delay, we got this. It will get too loud. Or, no, that's pre-delay, sorry. And now we can control it. And so this will give us our infinite reverb, but let it sort of restrain itself as it goes. And it feels like we are kind of in the zone. See, now it can't actually peak too loud. I would like to have it, see, I don't want it to gate exactly, but I want it to be able to hang on to like full sustain better than this. This is literally full sustain. So that's too much, clearly. And we'll just let it go a little bit more. Maybe you could do with a little more mojo here. There's something to be said for having the reverb require sound in it. I don't know, I feel that's falling away too fast though. So let's quit out of there and jump in and see what other things we can try to do. See, we've got feedback sum. I'm pretty sure with 2 more zeros I would get exactly what that was again. But that's not necessarily what we want. Also, we could manufacture feedback sum out of this output here. That would work too. But not really though, because this is all of those, this is absolute values of everything added together, whereas this is non-absolute values of everything added together. So this is actually going to be more effective as far as choking the reverb out. My question is, so I'm doing that, and then I'm applying this. Let's move these back up again. And by up, what I mean is back to here where we're using it. And then here's where our samples actually come in. So what would happen if this was our reverb amplitude? Then we're doing this, but first same as we added all that other stuff together. Underscore. So that would be the input volume coming in. That would be like the guitar as it is playing. And then this would be the absolute value of it, because we want it to go between 0 and a high number because we're subtracting from regen by this. So then we take that and do it for both of the channels. Because besamp L and besamp R, that is another factor for how we're basically doing this. I don't know why I called it bez, seeing as, yeah, okay, that's not, for buffer L and for buffer R are the filter. Bez is actually just the down undersampling. That's fine too. That is not wrong. So now we've added the input, and then we have multiplied the result of both of those things being added by a incredibly, we're scaling it way back, and then we're attenuating it further. So by the way, if I did this times 0 million zeros 1, which I originally thought was not necessary, and turns out that it is, before adding this, I would be stomping the regeneration into the ground the instant a new sound came in. This is modulating the reverb, the feedback loop. This is also something where I could have the feedback be a runaway factor. I can make it be slightly larger than regen max. By how much, I'm not entirely sure. But I could set regen max to be slightly more than I need. Like where it's 0003, we could go from here, and then it will start getting louder as it goes. It'll start making up its own audio again. But I'm also having it clamped by the input signal coming in, so now we see what it does. And I haven't done the early reflections. I think it's fairly likely that I'll get to doing that early reflections thing by the end of the day. This is me basically just playing madly with it, as one does, and trying stuff as I go. So here's our sound. I will include that snare, and I will include a bunch of empty space. So let's see what we've actually got. If we hit this at 0, no matter what the rest of it does, it is in runaway mode. So let's first of all see what it does with that snare and whether it rapidly gets louder and louder or not. No, we haven't got to the point where it's getting louder and louder. So maybe there's some fooling we can do there. But we can make it step on its own amplitude here. And that is stopping it from going out of control. But it is still actually falling back rather rapidly. So 2 things. Firstly, let's make that 4 times as much feedback, because we can do exactly the same test. And secondly, these will all take effect, but let us do the attenuation here, meaning that we're still dialing it back a whole bunch, but now adding these sounds, adding the sounds coming in, I'm scaling it back a whole bunch to be sure, but I'm not scaling it back and then scaling it back again after adding the input sounds coming in. What the change here is doing, the actual feedback stuff is going to be the same either way. But I am now not attenuating this part twice. Only by this, not also by this. I could also move it over so that I'm only attenuating the Bez input sample by this, but that's for, if this doesn't work, that'll be for the next try. We are scaling it back in 2 different ways. One of them is by 100th and another is by 1,000,000th. Because that is how sensitive Regen Max is. Now let's see where we got. So yeah, now our max regeneration is substantially more, and 4 times more max regeneration than was previously there. Point being, I should be able to get it so that that snare hit, it'll just start getting louder. And then when the sound comes in, that's when it maybe starts getting quieter. But I should be able to make this so that it is a sustaining householder reverb that brings sound out of nothing and just starts to make a wash. And then you'd have to set regen to be something less to not have it be an infinite wash. I'm not honestly sure why it's not already doing that with the regen turned up all the way, but something to do with I don't have the exact number available for it being truly infinite reverb. And I'd like regen to be truly infinite reverb, except for new sound coming in supplants the sound that was already there. Let's see what we got. That is sustaining well, but it is still falling away. So we can make it hush up pretty good this way. Might even be worth doing. We are starting to get in the zone. Okay, remember how I said we could do this the other way around? We can do this the other way around. if I do it this way, it is now suppressing the regeneration, but still allowing it to be there. So that is going to have it average out at a volume level. The combination of that and the initial feedback amount will double it again. 8. We'll keep doing that until it sustains the snare hit. Just goes. But then this part will bring it back down again. So it will make, if regen is cranked all the way up, it will find a maximum reverb volume to make when nothing is happening. And it'll go to that level and stay there unless you do something to stop it. And then, when new sound is coming in, that gets rid of the original sound so that the new sound can come in. And we'll hear that in the guitar. When the guitar kicks in, it'll suppress what's already there. So this is probably closer to where we're getting. See, the sum multiplied by this amount. Then we add the input samples and cut it back by only this amount, which is a way larger effect for the raw signal to have. Last little drip of coffee for the day. This is probably going to end up being a reasonably satisfying day as far as the reverb coding is concerned. Oh, have I not? Hang on, let's build that again. Make sure I have the real current version of it. Let's include some of these little guitar ticks as well, but not the sweep. Going to see whether we got into that zone of actual feedback. We will know if this is set to 0 and it takes off. It's falling back a little bit, not all that much. Now this is going to take effect very aggressively. Oh god, yeah. Oh, it's way too much. The instant it's making a sound, it's suppressing the other sound completely. Now when this stops, that's when you get the input sound. But the instant another sound happens, it replaces what was there. It utterly replaces what was there. And that low frequency replaces what was there. So now we have basically an infinite reverb that chases along after what the most recent sound was, but as soon as the sound is happening, we can't hear it anymore. So, how do we go about dealing with that? By having it be a additional factor. So let's see. Now we have this happening in 2 places, so that's too much. But if we take away one of these zeros, and then all but one of those zeros, that adds up to the same amount. So let's fool with that a little bit. Take one or more of those zeros and move it over to here. Each time we do that, the amount that guitar sound entering suppresses everything else, gets attenuated. So all I got to do is take zeros from here and move them over into here, and I'll be dialing back that guitar more and more each step of the way. I wonder whether they should really be closer to the same number. Like that. Let's find out. And again, the overall attenuate is going to determine how much of this is kicking in. Also, let's keep trying to make this feedback on itself. That'll probably do it. I was close. Actually, let's take it to here. Wouldn't it be funny if that was like pi or something? So we'll find out. If this works, then we implement the averaging. Let's see what that does. Back we go. And we find out whether it's actually going to run away this time. Not quite. It sounds pretty infinite, but not really. Okay, so not enough. But that's controlling it. And then it's kind of falling off. And then it's taken off again. I feel like I could do with having such a loud sound, replacing things more thoroughly. But all in all, we're moving in the right direction. Let's see what happens if we pretend that we did want pi here, but kind of offset. There's no reason it would be, mind you. Then there's attenuate. So again, more zeros here means we are suppressing the amount of influence that the overall regeneration has to stop it from being louder. So the less influence feedback sum has, the more it will continue to hang out being infinite sustain at a loud volume. The more effect feedback sum has, the more it will force itself to fall back if it is loud. The more effect this multiply has, the more it's going to get the sound out of the way when the new sound comes in. Now, currently we do not have all that much going on as far as like forcing it to be quiet, but if we had it at full volume, it would be completely overwhelming. Like it would just shut the reverb off instantly as soon as a new sound happened. So what I'm thinking about is let's move one of these zeros over to here. Less of the overall like compression effect on the sustaining reverb and more of an effect on this. And we're also seeing what the going and finding secret numbers, like a extension. If this is really close to being complete unity gain feedback, maybe I just continue this out as more of pi, but divided by this much. There's no special reason that that would be a magic number for this, but you never can tell when the stuff that you do ends up calling for some kind of interesting number. Golden ratio pops up all over the place, stuff like that. And we are fairly close to using pi as that number. There's even a test we can do. As long as I make sure not to use this, not to save this, rather. we've now got a longer silent section. And I can go even beyond that, but for now, let's see what we got. Infinite sustain. Not bad. And then this needs to kick in. Here we are making lots of more audio happening. And it's hanging out being loud, but it does actually back off a little bit. Now I could make a very long silent passage after this. It might be fun to do. Or a long silent passage after that. That's also... So here's a concept where if we set it like this, you just need to learn not to put that much gain into it. Or we can continue to modulate it. Let's quit out of there and don't save those changes. Do I have pi kicking around here somewhere written down? I am most certainly making a reverb using some of the newest reverb impulses that Into the Matrix creates. And I want to take a moment and let's see, Chromium, new window. Oh, did it wrong. Pi, not Pillager Base Farm. Not Pi Pizza. Let's see if I can hit return and have it not fill it in as Pi Pizza Farm. Okay, close enough. I am now looking on my computer screen at a version of pi, which is a goodly number of digits, although not all of them. Not that there is such a thing as all of them. 3.1415926 5359. So that's even more of sneaking the pi constant into this. I should think it will be able to be larger than galactic. The question is whether it's going to be good, and this is my hope. Hopefully I can get it to be better than galactic. Seems like logically I should be able to. I think that's about as many digits of pi as I can fit into a double. I'm not completely sure about that. I could also go pi times 0.00001. And how would that work? Let's see. So for 0.1 times pi, that should give me about the same thing, except for it is as much detail as the computer can handle. We shall see whether that works, but that's neat. And what else were we doing? We were doing stuff with this. Times attenuate A. We could try that. Just make feedback sum even less effective. It's multiple times what BezSamp L and R actually are. But it is our compressor in a very gentle way on the overall whole size of the reverb. And I've got the samp coming in and suppressing when new audio is coming in, and I've got a nice example for that. But there's a number of things I want to try with it. One of them is seeing whether my pad calculation there is correct. Rather than typing it out, I get to use the actual content at full double resolution. We'll see what we get. And if I can get into a useful zone, well, I can do two. Well, no, I can't, can I? I can do two experiments except for if I set the one thing to be literally 0, it won't do what I think. So over to doing the experiments and seeing what we get. I had none of that snare. That's fine. Okay, so it's acting kind of infinite. So if this works, I can assume it is a scaling of the Boulder ratio. 1:6:1:8, see? I feel like we can probably pull this off even more though. Or more pi shenanigans, perhaps? Does this amount scale it back nicely? Yeah. It's like overwhelming. It's clipping. But it's aight. Yeah, if we do this, you still have to be careful or you will overload it, but it keeps itself in check fairly well. So there's another possibility. But then here's the question, do we actually get to a state where it's true infinite reverb? And we're going to find out with that snare hit, leaving it set the same way. So is there a loudness below which it will not fall? There's supposed to be a loudness below which it will not fall. The idea is maybe do something where you could set it up so that it would just sneakily build clouds of sounds out of tiny little stuff that you put in. However, I don't think we're there. It's dropping below 60 dB. So here's the thing. What happens if we take away... Yeah, see, it's still falling. What happens if we take away this regeneration clamping? Ah, okay. We've got... No, we don't. We don't have runaway. Sorry, false alarm. I was reading it wrong. The number going up means it is not actually feeding back, even though I've got no attenuation on here. That also means there's not going to be any clamping. So my whole shenanigans with pi are meaningless. No worries. Let's get into our further experiments. Firstly, I don't know, let's see what we get when we have this as a factor of 100 rather than a factor of 1,000. We can still shut it off, but then here's where we were left off. What if instead go straight to 3.2? At some point, increasing this is going to lead to a situation, and this might be the one, because this is looking like it's combining these different, like 8 or 10 different values back into each other. See, the way they're being assembled is 0008. It's being attenuated by that much. But we are also feeding the same thing into the input again. So there's going to be an amount, and I'm figuring out what it is. It's not going to be 008 because we're already very close to a feedback point. Let's see where we got. We're doing the feedback experiments now. They involve blanking at everything after this point and just doing this. In fact, I can include one of those guitar bips because then I'll hear how much the snare replaced it. But first thing we're going to hear is, are we in a point of literal feedback? Yes. It's sneaking up. It's sneaking up, and it's going to sneak up faster and faster. It's only getting louder until we hit the balance point here. And using this, we will figure out what a suitable balance point would be. Here we are at 0.001. So now we have an infinite sustain. This is K Cosmos in an early stage of development, granted. And then as it cycles through, it's going to get louder, but it will probably fall back. It's kind of trying to still get louder though. See, here's where this control comes in. Ooh, looks like I could stand even a little bit more. This will end up attenuating the sound. even in this full-on sustaininess. See, now it's falling back. And that made it so that the new sound coming in pretty much replaces the previous sound that was there. So we've got it to a point. We've got it to an interesting point. See, 0.2 here. It's tending to hang around with the amplitude. This amplitude is sitting at about RMS 24 dB down. So now let's stop it and save what that was, and then undo the subtraction we did and start from the beginning. What do we get out of this monster? Because as you can see, we've got our drums and stuff here, and then we've got the guitar, and we've got the sweep, and we've got alien kittens. What does it do when we throw all of that stuff at it at full sustain? Well, it's not going louder than this now. Yeah, it's taking the infinity and leaving it... Oh, and now it's doing a subsonic thing because it picked up on that too hard. And now it's crushing it to nothing. So what happens when we dial this in? Okay, this is interesting. Might need a little work. We are very sensitive to our input sounds coming in. But it's striking kind of a balance. So what's happening with this now is it is replacing sounds very aggressively when new sound comes in, to the point where if it gets loud, it's really choking out their other sound. But it's not dialing back the sound that aggressively. So that subsonic sweep there cut the volume back very aggressively. And then this is clamping itself real hard. So that's interesting. The whole scaling works. This setting on Regen Max works pretty good. I don't know if it's really getting into runaway. And everything depends upon these calculations. When this has more zeros in it, the new sound coming in has less of an ability to clamp the heck out of it. When this has more zeros in it, it does not self... I remember adding one. Let's see what happens when we just attenuate everything more. After all, we still have a lot of range on the control for adjusting with. In fact, we can be a little sneaky and add a 1 onto the end of that. Assuming we are in infinite reverb, we are now in beyond infinite reverb. And then we need to have this working in order to get anything out of it. Let's see what transpires. Now the danger with that is if you have it literally getting into reverb runaway, getting into uncontrolled feedback with a clamping factor, it will start dragging up stuff out of the silence that is not necessarily desirable. I can start it at silence and it'll maybe just start making stuff up. I don't know if it will, but there's one way we can find out. We can firstly try this again and dial it in with our full crank guitar so we can get to a stage where we know if we have the guitar blasting, it won't go insane and out of control. So that's working. Oh, it's taken off. It's getting louder. So here's the thing. I can load it up with loud sound. But I'm hopefully not going to have it loading up with loud sound, which only then continues to get louder. I'm shooting for a sort of happy medium. I'm shooting for a situation where, like, these bass thumps don't just stomp on the volume immediately, but then the loud sound does have an effect. So let's see where we're at with that. Currently, if we have no sound, it doesn't take off. And now it is. So now we have a compressor but it is beginning to take off a little bit. See, it's getting louder and louder, but do we not have enough control over it? Wow, okay. Didn't expect that. We have another adjustment to make. I added too many zeros in this one. This one needs to have less zeros in it. So now that feedback effect is going to be 10 times more effective than it was. Which is almost certainly going to be enough. And components. I should honestly do this with the filtering, but we're currently doing it just as a raw householder matrix. Back into the zone. Oh, let's leave that sweep in there. See how much it replaces. And here we are. F is extremely high now. So high, in fact, that it's clamping it down completely. It's sustaining at a good enough level. And it's getting louder and louder. This is cool, but it's a little out of control. See, it's not pulling back at all. But as soon as a new sound happens, there you go. And you'll notice we have a special number in here. That might not be the number we want, though. Yeah, as soon as it does that, I can't hear the guitar anymore, so that's kind of too much. And okay, so here's the next question. Put that back. Less effect from the guitar, more effect from this. Let's see where we're at. Could be putting on something besides this, but what the hey. Silencio. Oh, no, let's start with this snare. Let's hear what that sounds like. Ooh, getting out of control. Okay, so this is becoming a little more interesting. Now putting this much loudness in it is excessive, but it's kind of sort of being restricted. Within about 10 seconds, it's no longer clipping. Within about 3 seconds, that one's no longer clipping. but I bet you we have a working bass level. So let's do one further experiment with it set at 0.3. Namely, silencio to all of you, and run it in the whole entire thing. And I got to run to the facilities, but I'm going to leave this playing so that I can hear what it's doing in the background. And then you'll hear what volume level it settles on after all the drums are done. Alrighty, it's hanging out at under 60 dB down. I could exaggerate that a hair. See, the higher I push this, the lower the bass setting is going to be. But quieter noises than this will come up to this setting. Pull it back to the baseline sound of the universe. And I can demonstrate that thus. Even more silencio. And then we do only one little bip, which is going to start out most likely quieter, and then it will swell. Let's see if that's true. This should start out not at full crank, and then get louder up to the point where it has reached its equilibrium. Now, I'm not completely sure that's what's going to happen. But I think it might. Yeah, our RMS is very slowly creeping up. Magic of the householder matrix. So you can do this. I could have a guitar patched into this and just be making little touches and scrapes and things on it. And I would probably get a lot of hum as well eventually. but this is doing a thing of bringing out stuff that is barely noticeable. What I wonder is whether doing the averaging filter is going to step on this too much, or whether it needs to be a control of its own, maybe, or whether it can ride on the filter control. I'll get more. You barely notice it though, because it started out much quieter. In fact, let's try that again and have it be much quieter and see whether it swells up from quietness more effectively. If instead we start with that. One thing about it, this is not going to be a loud noise starting off, but we'll find out what happens. Here's a little famous beep. So this could be what Cosmos, the plugin, is capable of doing. You just set regen to 1, effectively infinite, and then as long as you don't have perfect silence, everything in there gradually creeps up to become a universe of while still sounding like the initial sound. So you can start out with just making the delicatest, faintest little sounds, and they will build. I don't have it set up so that they're building fast, though. Although it's doable. In fact, it has me wondering, like, given that this is to be the crazy space ambient cosmos, maybe this is a good speed at which it should ramp up. Here we go. Another cycle. Oh, you barely even notice. So yeah, if it's a space ambient, if it's a space ambient plugin, is it more correct for it to be swelling up to full volume over the course of like 10 minutes? And granted, if you put a really loud sound in, it immediately becomes full crank, but then it'll compress that somewhat. So we've got a dynamic changing factor from both directions now. It will make the super quiet stuff gradually creep up and become the secrets of space, but loud stuff that you put in will gradually chill back down again. And it all can happen over the course of minutes. Like, this is still that 124 dB down, very faint thing, but now we're up to about 29 dB, and we'll get a little bit more well, you barely notice, honestly. It has me wondering whether that can be living on a parameter as well. Oh, also you can do this. Deres. It'll just keep doing it, it doesn't care. Mind you, new sound coming in will relate to the... In fact, I will let it do that. Let's swoop back up to here for a moment, just until it comes time for it to hit that tiny faint bip again. Oh, it's taking minutes. And our background space is hanging out at around 26 dB down, which is probably about correct for what you would use. But as it gets closer to that little dot that we can just barely see, now the dot's going to be entered at a different pitch this time. Oh, but it's still so quiet you can't even hear it. Well, never mind. Hey, an octave. So I could use the so that I have some choices that I can make here. If I use crunch code instead of cream code as the algorithm, you'd be able to sweep the pitch up and down continuously, but there will be more in the way of artifacts, which I'm not enthusiastic about, but it could be something worth playing with. Like, even using this one, it's got this smoothness going on. At really low pitches, it acts like it's continuous, but it's really not. So because this is the cream code algorithm, it's using integer divisors, which means there aren't any weird overtones on top of it. And you get to snap right back to this, which is sort of full range. If I use the crunch code algorithm, it will continuously sweep down at the expense of having a nasty digital overtone, which I'm not sure I like. Although I suppose I should try. Here's where that's done. That's the one that hard locks it to exact subdivisions of 1. Without that, it's a lot more normal. And then, this is what you do if you want this to become crunch code instead of cream code, sorry. All variations of the same undersampling algorithm. So now we are on the undersampling algorithm that is continuous, and I want to hear how good or bad that is. Oh no, we can do if it turns out that the cursed retro mojo is actually desirable, I can totally do that. I'm a little bit skeptical, but all the same. Silencio and silencio. So it's probably gonna sound the same for a start. Maybe not. I kind of hear the cursed retro mojo a little bit. There's that tizziness, which I don't like. But that part's fine. I just don't like the glitteriness of it. But yeah, that is the cursed retro mojo that we were talking about. It's just a question of, does that work for K-Cosmos? Now, 2 of those attacks at slightly different rates. So I'll tell you what I don't like about this aspect of it. The cursed retro vibe. Yeah, I know. I could do that. I could do something along those lines. I'd probably want to smooth that too. Another possibility is to hard switch it so that no matter what you're doing, it's only crunchy if you take DRes off one, because DRes will effectively handle multiple sample rates as the cream coat version, the version that is locked. Or you can make it do the crazy by manipulating it. But let's say, since it has the infinite reverb anyhow, see, I hear that sparkliness. But we can effectively stop the sparkliness by forcing it. Oh, no, don't save. See, what do we got here? Okay, so DRes will not end up being larger than 1.0 at high sample rate because it's going to have to adapt to that. But we're going to apply Tizziness removing cream. If you're using the plugin, you crank it all the way up on the DRes if you don't want the unpleasant tizziness. As soon as you take it off, instantly you have like, and then you can swoop it up and down. I should probably also add control smoothing. That's probably worth doing. Equals. All the nines. Okay, so that's a logical expression, so it is going to be true unless it is not. And we only run that if it is the case. We'll already be able to hear it, except for not really, because there's another factor in there as well. This needs to be different things based on what it is. See, it always starts at 0 if you're actually not having the nasty tizziness. But if you're not, then we adjust. That should fix that part, although I have not yet done the control smoothing. And it'll want that. No question about it. One thing at a time, though. Let's see if we can use that sound and demo it and see what we got. Silencio. That's that Beavis and Butthead reference. Silencio, I am the great Cornelio. Now, we're going to have multiple ways of doing things. That's interesting. Didn't expect that. Maybe I want to deal with that. It's just because we're at 96K. It's jumping up where it's not supposed to. It needs to take that into account. Let's do that. What am I getting wrong? So the switching part's okay, but the rest of it not so much. What do we gotta do? Divide it by overall scale again? Why would that make any sense? Why is it doing what it do? I ask you. So as we cycle through, this is fine. That's fine. But it's bouncing to a higher rate, which is less fine. Let's see what happens if we do this. So that is not forcing it to be subdivisions, but it shouldn't do anything. And that's what confuses me. However, we'll find out whether, oh, didn't like it. And then tell you why. Got to do this. So that shouldn't change a damn thing. And yet, we'll find out. And the one thing I'm not doing is I am not forcing it to be an integer. Let's see what happened. Oh, still doing the same thing. Yeah, it's kicking in the first available. So that didn't do nothing. But what if we divide it by overall scale twice? Can you do it? Can you divide by overall scale twice? We're going to find out. Like, that shouldn't do anything. That shouldn't have a result. This shouldn't be necessary. We're already applying it once. I don't know why you would need to apply it twice. And yet here we are. Different sound this time. Nope, that's not right. Completely not right. Like, I can get it basically right, and yet not so much. Okay, so this is getting even more interesting. So dres can be that divided by overall scale. Sure enough, you don't want to do that twice, but what the actual hey? So let's just build this into a couple of experiments at different sample rates. Oh, there's no such thing as too ambient for this plugin. I tell you that right now. Goodness no. So the next experiment is we will reproduce what it was doing before. Up to and including the original noise. And then we're going to downsample everything and see whether it acts the same. It'll jump up. Yep. So that's interesting, and I didn't expect that one bit. Now, we go to CD sample rate, including a resample, so it's the same tone. Okay. Really didn't expect that. Now it's at exactly half. Okay, brain explodey time. What in the world does it think it's doing? Alrighty. Well, this stuff needs to be the same. Okay, so here's where we were at. And this is actually me being stumped. There's presumably an answer. So dres param b divided by overall scale. If you just use it raw, dres ends up being twice the rate we want. If we're at 96K, it's a different rate. It's like we're applying some kind of funky processing, and the correct pitch for the 96K version is exactly where the second stage down would have kicked in. I could force it all to be a lower pitch. We could try to force it to do that. Let's go back to one of the tests. So if we do this, it is exactly the same either way, but we're handling the zero case differently. Either it goes literally to 0 or it goes to -1, which is not quite zeroing it out completely. Let's see what it does when we hit it with this. See, the challenge with this kind of stuff, and the reason it's important, is I could go around asking like ChatGPT, what do I do? What's the answer? And it doesn't know. Nobody's done this before. Maybe if it's really clever, it tries experimenting with things, but so am I, you know. I don't know what it would take to get to a point where it would do this kind of thing and be able to work it out. Silencio. So we're at 96K. And it should go to see, it goes to here, and then that's the correct amount. So I'm forcing it to a different rate when DRes is this. How close is that to? So what's happening, it's like my math on this DRes thing is not quite what I thought it was. So I can set it up so it tries to divide by 0. That seems bad. Because if I tried to crank it up so that DRes was 1, with their little sanity checks there. What if instead we take away this int and see if it does anything similar? I feel like maybe it's not going to, but for that matter, let's see what it does if we make both of those. Or we could use a different form of flattening. See, casting it to int is just going to throw away whatever is beyond the decimal point. Doing floor is going to throw away whatever is beyond the decimal point. But this might be different. And we might not even need to do anything more if my guess is correct, which it may not be. Let's take the snare. What the hell? It's not going to matter. It'll either be correct or not. Nope. Yeah, we've got a built-in pitch jump there for some reason. So that ain't making any sense. Can we force it to work somehow? After all, our max is 1 divided by overall scale. So bear with me. So it's a factor of about 2.1, but that's not what we're getting as a pitch. Not even slightly what we're getting as a pitch. It's got to be something else. What if we do this? We're kind of groping towards an answer here. Nothing, no sin in that. It's worth a try. I need to start the program first. There we go. So I'm thinking maybe the way to get to it is times equals like 2 divided by overall scale, or no, that doesn't make any sense either. I can get a rough sense of what I want it to be doing. I just can't make it do it. I don't want to just plug in a custom number for each time. Like that's fine. And that's clearly too low, rather than formerly it was too high. Then converting it to 44.1, run it again. And now that does the opposite. It goes up in pitch. Does that mean I just have this backwards? Dres divided by 1 divided by overall scale? Like, that makes no sense. But on the other hand, it might actually, well, no, wait, no, it wouldn't, would it? That shouldn't do a damn thing. Except I know that the change was happening reversed. Back to the grind. A little silence. A little more silence. So if I can get any of it to make sense, it'll be great. Ah, that went up. And then if I convert the sampling rate, it will still be a higher pitch. But now it's the same higher pitch. Okay, we're getting somewhere. Two divided by overall scale. Let's see where that gets us. We might be onto something. This might be the thing. If it isn't 2, it might be 4. So that gave me the same pitch each time. So now all I have to do is get it to give me the same pitch, but the same pitch in literally the frequency I want. Oh, have to start the program. All caught up in trying to figure out what it's going to do. And then I have to test it by actually starting the program rather than just looking at the screen. Yay. On. Word. What have we here? Well, I don't think that's what I intended. Try it again. That's like a fifth up. Doesn't make any sense why it would be that, but it is. Convert the sampling rate to 44.1K, making some of these end up being like effectively 1. Okay, now you're happy. Now it's fine. But the undersampling part's posing a challenge, because it does this. That's not the golden ratio. Oh, is that exactly a third? 2/3? Okay. Plugin is apparently possessed by Satan. That is exactly the right number. Probably 2 more decimal places than that. But it only works at high sample rate. Okay. That means if we are at 44.1K, it's DRes divided by 2. If we're at 96K, we are a tiny bit over that, so the sample rate becomes like 2.1. So, what are we doing? So 2.0 divided by overall scale. Overall scale for 1 divided 441 times 960. It's 21768. If we have DRes divided by 21768, our pitch is wrong, but exactly 2/3 of this resulting thing becomes perfect. Well, there's another crazy trick I can try. There's no reason to believe it'll work, mind you, but the square root of 2.1768 is 1.475. 2 divided by 1.4, well, let's just see what it does then. Because see, square root of 1 is 1. So this is perfect if you are at 44.1K. But it's not if you're not. So it becomes a matter of like, what further madness do we need to unleash in order to get it into the zone? Because it's doing a very bad job of getting it into the zone. It simply does not want to align with anything sensible. I guess nothing to it but to do it. So if that is 2 divided by... I can't think it out. I'm going to have to just try it and see what it does. And if that works, I try other sample rates, like 192K, and see what that does. Because we are really out on a limb. I do not know what I'm doing. I hope it works. It's not impossible that it'll work. But this is that borderline between genius and being a complete idiot that is worth attention. And again, I can convert the sampling rate and ensure that it is in fact working at exactly the correct sampling rate. It should. As expected. So that's fine, but our problems came when we were doing it at 96K. Oh, it wants to go a little higher for some reason. Square root. I could not tell you why that did what it did. But you know what I told you? I needed to test it out on other sample rates. We can find, oh, we don't have actually 80. We have 64. I'm not sure if it's going to run in 64. We got 192. Let's see if it even works. Weird, okay. So it goes a tiny bit over for no reason that I can see. But so did the other one. So if I come up with enough of an adjustment that it's able to handle this, also, here's a cheeky thought. When I have a higher than desired sampling rate, the pitch as it transitions is too high. What if we have a lower than desired sampling rate? What do we do now? If it does anything at all, I think it'll work. Core Audio is very flexible. You can tell Core Audio to do all kinds of crazy things. Yeah. We have a situation where exactly 44.1K is dead on, exactly right. At least I think I can consider that to be correct. Maybe that's not even correct. Let's find out. Resample. Now. Oh wait, no, I've already got it open. What am I doing? Yeah. So at that, it's fine. As soon as I start changing the sampling rate, I'm way closer than I was, and the square root function appears to be in the zone, but it's just a tiny bit off. And it's off in a similar way each time. let's start by quitting out of here. That means if overall scale is actually 1, the square root gets me in the zone. If I take this overall scale and multiply or divide it by something, then it'll leave 1 alone. Well, no, it won't, will it? Dang it. Ah, but square root is like an inverse power factor. So dres needs to adjust based on its departures from overall scale. Let's try something a little silly and see what it does. So now dres is just going to be cut back by the amount that overall scale is. That should be exactly the wrong thing. On the other hand, if it's the right thing, it has saved a bunch of time and effort. But I think it's exactly the wrong thing. Worth seeing what it does, anywho. I haven't even gotten down to softening, spending the entire day on this. Dang it. Well, we'll see whether it gets anywhere. Silence. $96K. Yeah, it drops right down. So that made it go too low. Let's see what happens if we take it to the opposite, assuming that 44.1 is still completely neutral, because 44.1 is going to be divided by 1. Let's go to our 32, and now we see what happens. Ow. Deep pain and agony. Wow. I'm glad I didn't blow my speakers with that. That was loud. I'm not sure you can see I think my face might be hiding the meters. Oh, that just blew everything up real good. Real good. So that's all of the no bueno. But we can do that, and then it probably won't explode. Because now we're clamping the values to sane values rather than just making everything blow up. Let's try that again and see what happens. Probably nothing good. Oh yeah, no, it exploded. Exploded real hard. Back into the breach with the danger and stuff. Yeah, it drops way down. If we convert the sampling rate to 44.1K, oh wait, no. This is the one where I'm an octave off. Needs to not be that. And then if I set it to 32, so if I'm correct, it will not blow up this time, but it's not going to be good. Oh yeah, no, it went to exactly the same thing as before. So that's interesting. What have we here? It needed to be an octave down. How about divide equals overall scale plus 1? That would be stupid. That couldn't possibly work. I see no reason that that would be a thing. Gotta try it though. Because it needs to be divided. Oh, that would be so dumb. I can't even. If it turns out to be this, I will be so grumpy and laugh so hard. That makes no sense at all. Offsetting overall scale by 1 to make it work. And yet that is what would make the 44.1K case work. So what would happen then? It would be divided by more, but not that much more if it was a high number. And if it's a really low number, it won't be divided by as much. I can't even begin to guess. Somebody should write a scholarly paper on what this means if it does in fact work. Because this is the dumbest hack. Nope, goes way down. Let's find out. What we do at exactly 44.1K. The correct thing. That's predictable. So it went down by too much. And then we do have the clamping in there to make sure it doesn't blow up and go crazy, so we can try the other. We can try the 32. Goes up. Okay. Let's try something even stupider. Those are both in the wrong directions. What if instead of overall scale plus 1, 3 minus overall scale, for no particular reason? This makes no sense and shouldn't work. But it does get us that central point where if it is 44.1K, it will get us to exactly 2, and so that will work. And we're not worried about, well, we could, if that don't work, we can do square root. Why not? Why not? This has ceased to make sense half an hour ago. And the neat thing is this still works basically like a scientific experiment, because it's like, if it works, I will notice. If it works, I will know. It'll start doing exactly the right thing at every sample rate. I'm just having a hard time getting to why is it doing this. And yet I don't care as much about why it's doing this. I just want it to start doing the identifiably correct thing. If it does that, I will be satisfied. So we're now coming from the opposite direction. 3 minus whatever. No, it went up. And if I try the 44.1K, I can predict that is going to work normally. Yep, that's the desired behavior. And then if I try, let's see, firstly, at our high sample rate, it went up. At our lower than desired sample rate, it will theoretically go down. No, it goes up as well. Huh. That's weird. Why would it be departing in either direction? I mean, ideally, if it ends up being a working algorithm that actually works, it'll work on all of the sample rates I can throw at it. That's not what we're seeing right now. Maybe it's being affected by the fact that my undersampling only works if I'm applying a higher sample rate to it. In which case, time to try another variation on the theme. Because 3 minus overall scale did no good whatsoever. So how about square root overall scale plus 1? There's no reason that should work, but it will give us the same thing as far as if we're at 44.1K, it will actively be at 44.1K. Beyond this, we are in a world of mystery and do not know. I love how I drink my final coffee of the day and all of a sudden I'm struggling with this ridiculousness. I think honestly that's part of the point of these streams. I gotta get through it anyhow. I might as well get through it on camera. So now we're trying square root overall scale plus 1. That's going to be exactly the same. As long as I'm predicting that things are going to be the same at the base rate of 44.1K, it's been correct. As long as I get to dres divided by 2 or times 0.5 would be the same. Everything that works out to that is actually correct. My problem is getting to the high sample rate version, namely this. And it is too low. But is it lower than the other one? I know, it's all good. It's a thing. So what does it mean if it is a lower pitch than I want? because it's never like an octave or anything easy like that. If it's a lower pitch than I want, dres is becoming too small of a value. Dres is supposed to become the same thing that it's doing if it's the integer version. And the weird thing about it is if I force it to become the integer version, it's still not working correctly. See, if I do this, now it's going to do that every single time the same way. Now we're keeping dres being exactly the same each time. And I'm willing to bet you it's still going to act different because of what we're doing here. Either if it goes beyond, it goes down to 0, or it's larger than 1, so you subtract 1 from it. Those should be the same, but I think we're going to find that it's not. I think we're going to find that it's not. If it is the same, then we're going to get the stepped version each time. And beyond that, nothing else happens. Because we are quantizing it to the integer values regardless. And voila. Yep. And then it wants to get to this point. So effectively, when we're doing dres at a high sample rate, and we defeat the subtract 1 and make it forced to be 0, we get this. If we're subtracting 1, it goes to here, or it goes back only when we do this. But now we have the funny artifact. So that -1, that's where it gets you. This is it being set to 0. This is it -1. And then it's okay again, kinda, only when we switch to this. And then back to the sampling rate follies. If it's at the regular sampling rate, it's even more different. See, something wrong is going on here. So in theory, that should tell us something. So when we hit that endpoint, we should revert to 0 either way. If, however, we're doing the crunch code version, we're subtracting 1. It's checking against 1 So subtracting 1 should drop it down to where dres is kind of cycling through. And then this is the thing that is causing a ruckus. Could it be that overall scale needs to be applied after all this? I mean, that doesn't make any sense though, because dres is my way of getting the same reverb length and sustain irrelevant of sample rate. So it's a tiny bit different using the cream coat if you're going from 44.1 to 96. It really should be able to behave better than that. So let's have a think about this. dres can, if overall scale is 1, then dres can be almost 1, namely 0.999. So 1 divided by 0.999, or a smaller number, becomes larger. One divided by 0.5 becomes 2. dres getting dropped, such as if it's a sample rate thing, means it will jump to the nearest available downsample, which is not necessarily the same as you'd get using overall scale to do it literally. And that's probably where our problems arise, because we're effectively rounding it to the nearest available setting, whether it makes sense or not. And that means that I do, in fact, want to include it the way it's being included. So copy, paste, uncomment this else. Here's the part where I can't make any sense of it, although maybe this was closer than the other. Boop. 2 divided by square root overall scale. Also, isn't square root the same as the power of 0.5? I feel like square root is the same as power of 0.5. Well, I got a calculator built into this computer. Let's find out. Power 0.5. So square root of 4 is 2. That's just a square, so that's fine. So yx, so I believe that would have to be 2 to the power of 0.5 and if we square that, get 2 back again. Okay, that did give us a square root. So now let's see where things are going on the back of this. Because you see, if we can do square root by going power 0.5, we can do power something close to 0.5, which is not. Wouldn't it be funny as hell if it was the golden ratio? I would laugh and laugh. I'm not going to suggest that that's going to be the answer, though. I'm just saying. That would be the Airwindows thing ever. Being able to get it perfect by going, okay, let's just get the extension of golden ratio. We're going to use that, and it's going to be perfect. That would be deeply funny. Nobody would believe it. It would be just the silliest thing. So we're back to the power factor. And this is a previous version that, if I remember correctly, it kind of sort of worked, except for not really. And 1 to the power of anything is going to be 1. So I'm pretty sure I'm safe on the... Are we doing this correctly? Have I forgotten to do something? It can't be done. That can't be right. Is this just because square root is so inaccurate that it screwed it up? So there's the 44.1. It's perfect and fine. Here's 96K. Oh, no, wait. That's the tiniest bit off. But super close. Let's try all of our pathological cases. 192, 32. First, 32. See what we got. 32K, please. What happens when we do that? Up. It's off. And well, it should be, because we shouldn't necessarily have to deal with that. Now let's try 192. I bet it's also going to be off, but it's weird how this is a little closer than the square root. Not quite, but it's a little closer than using square root. 192K. Enable. What do we got? Pretty much the same as the 32, isn't it? So all I gotta do is fine-tune this power factor. Well, if we had it overall scale of just for laughs, we will try the golden ratio and see what it gives. Like, this should be incorrect. There's no reason this would work. Nobody in the inner core of mathematics would make this be a thing. By the way, Grands, weren't you having to make dinner or something? Are you hanging out late with me? I guess the amusement value is there. Oh, let's not block out that noise. Let's just silence after the noise. So it was very close, but it would bump up a little bit more than it should. This is now a power of 0.618. Yeah. So it was too high, and now it's noticeably too high, which means if we go to 192K, it should be way, way too high. If my assumption is correct, let's find out. Cool. And what that means is I went the wrong direction. 499. We want to the power of tiny, tiny, tiny bit less than 0.5. Oh, I'm going to have tacos again. It's Tuesday. I have a tendency of, on my streaming days, I enjoy tacos afterwards. So that's 4.99. Is that enough? I can find out. Hang on a moment. Hang on a moment. Let's not even do that yet. And I'll tell you why. Param G is available. If it is set to 0.5, I'm going to have to make sure that it defaults to a sensible value, though. I don't think you can do it to the power of 0. I don't think that's a thing. FG, you default to 5. That probably won't help, but we'll find out. Because it's going to load up the previous settings. So we'll just see whether this dies immediately or not. It's possible that it will. But if that works, I can set it to 192 and dial it in by ear. That would be quite funny. Silencio, says Beavis. And does it crash or does it not? If it doesn't crash, we can set this appropriately. If we do that, okay, that's weird. What happened? Oh, I hit regen instead of derez, that's why. I'm all figuring out what's supposed to be happening and I'm just hitting the wrong slider. So, now that G is set to 0.5, if I touch derez rather than regen, I should be able to make it bump up a tiny bit in pitch. But this will change the modulation of it. Meaning that now I can set it to 192K and dial it in correctly. So I don't have to experiment, I can just try it. 192. Wait, have to start over. I need to set derez correctly. Oh, come on, that can't be true. .38? What? Well, let's see if it makes sense. That worked. A little undo gives us 96K back. Is this now wrong? Yes, it is. Okay, that's unhelpful. So we can't fix it by power of something far away from 0.5. Power of 1 divided by overall scale. Oh, that would be stupid. That would be gloriously stupid, but what if? Power of overall scale and 1.0 divided by overall. Because that's going to give us something close to, oh no, but that doesn't make any sense. It's going to be close to 0.5 if it's 1 divided by overall scale, because that's going to give me just the hair less. But then if we are at 192K, it's going to be closer to 0.25, and that's not right. Well, I guess let's find out. Let's find out. Or maybe it's divided by overall scale divided by... That would be dumb. Also not correct, because then it would be 1 divided by something. Oh, let's try it. Never saw such a pain in the butt plugin. I'm going to take a break before it's time to defrost my cheese for my tacos to at least implement that softening quality I was talking about. Because this is all struggling over stupidity. I mean, I can force it to be correct for some of the basic correct things, but we're losing it on some of this stuff. Show me your secrets. Don't need G anymore. Weirdly close to correct. What if we're just faintly off? What if we're 48K? Because I'm pretty sure we're still fine at literally 44.1. Yep. That's fine. So for 48 instead, it's just a little ways off. So it shouldn't be that much of a difference. So far so good. Now if some poor sap is running at 192K, hoping to have this make sense and work, they are in for a world of hurt, but specifically what world of hurt? What do we got? Yeah, it's off. Should not do that. That's too much of a jump. Okay. So what is it doing? Can we get even stupider with regard to power functions and things? Is this some kind of horrible fractal? Is this some kind of horrible fractal where you have to continue the divisor on and on and on? So 2 divided by power overall scale, it's close. Very, very close. And 1, or it could be power of overall scale 0.5, and technically it's kind of even closer, but not if you're at 192. So if at 192 overall scale is way smaller, where's my calculator? It's like 4.3. So that's a fair bit off. So dres starts out as a factor of overall scale. It starts out as 1 divided by 4.3. That is even smaller than 0.25. It's even smaller than that. So that guarantees, even at the most subtle settings of it, we're undersampling. So we are always making only marginal contributions to it. Then when we try to do this adjusting deal here to make it match what the apply cream setting would be doing, we're having to go to int 1 divided by dres. Maybe there's a problem right there. Because divided by, it's the closest setting that you can get to. Which doesn't make it reachable with normal math. Presumably. That, or it is the leftovers What if we just got real frisky? We got a 1 divided by this, meaning it's supposed to snap to the nearest possible setting. What happens if we just grab this and plunk it in here? Copy. And then int1 divided by overall scale. Don't need quite so many parens. So that should give me a, it's going to still snap, but what else will it do? And if it do, can we remove that int and then have it actually behave itself and work right? Madness, but supposing it worked. We will start at 96K. Okay, didn't expect that, but it does something. So that's super no bueno, but something happened. We're pretty much trying to force it to get to that point. So 1 divided by 2.1, how about? No, wait. I have that backwards. 0.999 divided by, let's call it 2.1. Yeah, so that goes noticeably smaller. Oof. At least we're clamping it so it can't make everything blow up again. So using int for that is definitely not okay. On the other hand, if we're not forcing it to be int, is this going to just stick it at the same frequency? I feel like it might. I feel like I might have just made something that cancels out completely and is useless. And I might have to just leave the 192K case alone if I can't solve this, but I'd like to. It is frustrating. Some kind of factor of the integer factor of what overall scale is, like the overshoot. Because without the overshoot, I got nothing. So what do we have when we do this silly thing? Hopefully it won't just explode. Oh, no, it just went to a double and stayed there. So that's no good. These cancel each other out. This is as close as we got. Overall scale to it's the square root, so it's the power of 0.5. That's as close as I can get. except for I lose it at 192. So what can I do? I experimented with it, and 0.5 minus a tiny amount got me there at 96K. 0.5 exactly will be fine at 44.1K. I didn't really check much at 48K because it's going to be pretty damn close. Although I suppose it's worth checking to see whether it's like wildly off or something. But then when I tried to do a higher rate, so let's do a little experiment. Don't need the pen. Oop. So that's going to give me like 0.1 something on 96K. It's going to give me diddly squat nothing on 44.1. And it's going to give me a significantly larger amount, but always less than 1 on 192. And I simply wonder whether it'll give me insane, ridiculous numbers on anything else. But this is going something. This is getting messy. So we can do that. It's insane, but we can do it. I'm also a little concerned that 48K will blow up or go insane, but no, it can't, can it? It's too close. It will be very messy if it turns out that this is the thing to do. That would be a very silly thing. Having a hard time remembering what the key for silence is, and it's S. Just goes to show you I can't be drinking too many cups of coffee late into the day, so I'm kind of stuck doing my best. That pretty much goes a semitone down. But other than that, it's fine. At 44.1K, this should amount to exactly correct. Yep. Undo. Likewise, if it's at 48, hang on, wrong thing. It should function but not be too wildly off. It's off. It's not too crazily off. And then lastly, at 192, how far off is it going to be? A fair bit. So that's interesting. We're kind of in some kind of ballpark doing this foolish thing. So let's see, 0.5 to around 0.38 was what it took at 192K. So if we scale this whole thing, 0.5 minus remainder, because it's going to be 0 if it's literally over, if it's it's going to be what it's going to be, put it that way. So 0.5 minus 0.38. 0.12 is our target. 192K is 1 divided by 441 times 1920, 4.35. So we could try simply dividing the remainder by 4 and seeing how close we come. Same thing. Times 0.25 is the same as divided by 4. I could also tune that using per mg. Why not? Copy. Times like those that I need the coffees. Times per mg. We'll make it g. I'll try to remember the correct things to hit. And we'll start at 0.25 in hopes of not blowing everything up. And we're going to use the remainder of, well, the irritating thing with that is that 88.2 is not going to give me a remainder. And I don't know what that's going to mean to the algorithm, but that's for another test. Possibly a very soon test. So 0.25. Let's go. Let's see what madness ensues. We could have a thing that acts really crazy when you have a super non-standard sample rate, which people don't normally use, and maybe that's fine. Currently, that one's pretty good. We'll try the 192. Honestly, that's fairly, if somebody's using a crazy fast sample rate, it's probably going to be that. It's the standard. And we've still got this open, so I don't need to worry about that. Ah, interesting. We went up. Hi. Are you exactly a third? That works. Don't know what it means, but it works. That sounds a little higher. Back to 96. That's noticeably down. By like a semitone. And just for shits and giggles, we have options for silly sample rates. What do you make of that? Completely wildly off? Yep. Okay, so this is not really a method that's going to help, I fear. Oh dear. And I thought maybe it was going to help. But one further thing to try, I guess. Because the thing is, if over scale -1 is going to be 0, then it doesn't matter how big it is. So we can scale it like that. And then it will not have weird departures based on that. And 0.5 minus remainder, well, if the overall scale is 1, then remainder is always going to be 0 no matter what param g does. So this might actually be my path towards having it work. And then I promise I'm going to do the tonal thing after trying this, regardless of how it works out. I really wanted to see what it would sound like with averaging every cycle on this infinite reverb thing that is happening successfully for us. Come on, open up. Thank you. I know how to manipulate this. I've just been hammering away at it for hours, and so I'm a little fried. So, okay, Cosmos, and let's jump straight to the 192 case. I know that's the one that's going to be a bear. Boop. It's also making the laptop very unhappy, but I can't help that. And let's see, G. Let's assume it's a very small amount this time. And $192K, and it is working at that setting. 96. Are we wildly different, or are we still in the ballpark? I don't have to reselect that. It's fine. Pretty close. I'm tempted to find that satisfactory. It's pretty close. Oh, I did a wrong thing. No, I'm fine. Now, we convert it to 64K just to see what it does. And this time it's probably not going to be too insane. Spoke too soon. Yikes. Well, it was going so well. You know, the reason this is happening is because of that whole thing about making a change between a undersampled version that is a divisor of an integer and transitioning to whatever the unfiltered version of that would be. That's the problem. Oh, hey, Cablos. You know, I do in fact use a marinade on a regular basis. The thing about it, though, is that the marinade that I use is just nothing but brine, or almost nothing but brine. I take a piece of frozen chicken, and the way I thaw it out is I freeze them in little Ziploc baggies and reuse those. And then when it's time to, it's probably still frozen, but it's warmed up enough that I can handle it, as in open the bag and pour something in. I put in a little tiny bit of baking soda and some kosher salt and then some water. And then I shake it up until the salt dissolves, and I put it back in the fridge, and some hours later it will have thawed out. And it will be a little bit marinated, and it will be a little bit brined, but not all that terribly much. And that's basically about it. I actually have fancy soy sauce, which is really strong, but it's rather expensive, and I'm not likely to get any more of it anytime soon because it was expensive before and it's from China. But it's also too good to use as a marinade. So there's that. So let's get out of this 64 nonsense and go back to our transition here. And then we will either tune it in or just set it as the 192K case. I think ill will happen if you go to 384 or whatever, but I'm not prepared to worry about that. I'll settle for if I can get these correct rates working properly. I bet it's 375. And then if we undo I'm sorry for the poor computer. This is a vintage computer, and I'm asking it to process a giant reverb at 192K. That's mean. It shouldn't even be able to do it. I'm impressed. And now we see what it does at 48K and whether things are horribly wrong or not. Okay, it's a little ways off, but I honestly don't think I'm going to get any better than that. Nuclear vinegar? Seriously? Doesn't it cook by virtue of the radiation? Doesn't it heat up like a bomb? Or just, presumably, I guess you mean incredibly strong vinegar. 0.375. 0.0375 is my guess as to what that wants to be. And let's put it closer to where we're using it. Like that. 0.5, don't need parens in there because it ends up being fairly simple. I could combine it all together, but I think it's going to be basically fine. I don't know what would happen with our lower sample rate question, but I suppose it's worth finding out. Build. We have got as close as I dare. I'm not going to be using 192K. I think 96 is quite enough, but I know there are people who will, and I'd like it to behave nicely if they do. Because I've never tried or succeeded in getting crunch coat and cream coat to work in the same plugin, much less switch between the two. Nuclear waste vinegar? Okay. So, open this up again. I'm going to use this for it. I don't even care. Hit Cosmos. So that's fine. And then if I pick the weird sample rate, namely 64 I think was just a little off. 32. Yeah, it kind of lurches a little bit. You know what? Fine. The people at 44.1K will have it exactly perfect. So points to them, I guess. I think also 88K. Well, no, actually, I'm not sure of that, am I? And it's not really letting me use it. So at this stage, I'm going to put on a noise and rush off to defrost my food. I never did get around to doing the thing I said I was going to do, but I do not care, because I will in a moment. But we're no longer using that. I don't remember what this does, and I'm afraid to find out. Enjoy. Be right back. Okay, have we had fun swimming in the reverb for a while? The amplitude seems to be behaving itself pretty well. Stop! There we go. As promised, it's time to try to apply the filter. Also, what was that attenuate? So that has to sit at 3 or 0.3 or whatever it was I had. It's doing a job of some kind. I'm trying to see what kind of job it's doing and where and why and how. It was going to be from up here, I think. Yeah, times equals attenuate. So we need to do that. This being the... I suppose I could go and check and apply it. How about? Because the rest of this can just work along with... I'm also checking out how hot the poor thing's getting. This laptop doesn't want to deal with this stuff. Oh no. Yeah, let me go and find that out. What was I using? I was using this setting. It is 0.3 exactly. So from 1 to 0.3, and we got there. That ought to work reasonably well. It looks about right. And we can probably leave that stuff alone. Everything uses regen, doesn't it? So if I do that, it gets only to half the gain, but I'm going to be using the filter. And I want to see what that gets. Hopefully this will work. And now the remaining bits are prev each of those things. Wait, I scrolled too far. Back we go. There we are. And now that I've done that, now we reassign each of those things, now that we've used it. At which point it should work. That's how that works. These are the spots where if I get a typo, I wind up with unfortunate results that are hard to figure out. Now, if I do that, I should get a neatly averaged filtered result, which will be more filtered if you deres it. And I have adjusted regen to compensate for using 2 copies of whatever it is. One of them is time delayed. I don't think we're going to get around to doing the early reflections in this. And that was one of the hopes, is to do early reflections, because it would find uses elsewhere. But it's been a long day. And it's time to find out. Oh, come on. Come on, you difficult thing. What my ultimate sustain thing sounds. When we slowly creep up in volume, but now it is filtered. And we're no longer using that. Boom. Ah, it quickly darkens. We get a rapid darkening effect, in fact. Without having to do anything else. This also means that when the new boop comes through, it will sound different now. Yeah, see, we're not getting a runaway of volume, but the sort of regen quality of it. We are getting a background that is the combination of all these things. And low end is kind of creeping up. Throw on some other sounds. Do the same thing with it. I'm liking the way that happens. Also, the neat thing about the 0.5 and adding the previous one is that it is using that shifting a bit thing, so I am retaining clarity. And we can deres it or not as we see fit. And that gives us a higher pitched one, but any digital artifacts soon get washed away. I was going to smooth that control. It's a pretty straightforward operation. Let's take it at a slightly off. So this is supposed to be crunch coat, and it is. But I like the overtone now that it's being filtered just a tiny bit. Let's stop this and try it with something else, just for fun. Let's try it with these and repeat them more often. It's going to get louder. I'm liking the idea of this being the Cosmos texture. Loaded up with drums. Now it kind of fades away. Or Here's a thought. We could have it be tied to DRes, so it gradually darkens if you have the DRes on even slightly, but if you have it full crank, it's not filtering. And then it can be modulated, and I've already got a setting that I can use for that, namely, oh, not using that. Where'd that go? There it is. I've got the setting apply cream. We might have some changes based on what happens here, but I think we're probably good. Might be bumps in there. That's probably fine. Let's grab all of these. It's safe to assign them to this if we're able to completely blank them this way. Then it's all in the same calculation. And we make them all be 0. So if we do this, there's our regen. If we have and are using our previous samples, we instantly switch to using that. They're always there, but if we are not applying regen, they're instantly zeros. And if we are applying regen, regen is instantly half. So that should work for switching back and forth rapidly. And that might just be a useful tweak on how to make this go. We shall see. Trying to think of what else I wanted to try. I mean, granted, one of the things I wanted to try was the early reflections. I know that. That would be on a control. You wouldn't necessarily want to have it there. But then a lot of this other stuff warrants its own behaviors. Settings. And let's incorporate a little bit of loud drums and then get to playing with this and seeing what it do. because our full brightness is at no deres, but as soon as you start deresing, we're going to get into a zone where it's slowly darkening, but it's actually going to darken more slowly at these low settings. Set it to deres, and the distance kind of goes away. It'll just slowly start going darker, or you can have it be full bright. So we can have that high note hanging out forever. Or so I'm of two minds as to how well that's working. I mean, it works. I could also make it right on the filter. That's the thought. How would that be? Maybe it rides on the filter. I'm trying to avoid having it be... I want it to either be full on or the averaging factor, but not a combination of the two. So let's see, we can have an additional thing. There's our filter. We'll steal this and use it. Here's how we calculate that. And then we sneak it in, and we're going to call it apply average. And we apply average if it is less than 1. So if the filter is cranked all the way on, then the decay will not darken. And it'll be a kind of abstract sort of sound. But any amount of average, any amount of filter will also make it, which will make it fall back off into the distance as well, which is correct. So let's see where we got this. That part's fine. This part's fine. This is the part. So if it's cranked up, then regen gets notched back. Otherwise, these get zeroed before they get used. Let's see if it worked. Impulse response would be a half an hour long. Or inaccessible, because some of the things this does can't be done with an impulse response. You're supposed to be able to manipulate it as it goes. Let's try it on a different sound. So now filter will do the job. Derez, same as before. But any use of the filter gets us the dark spooky space. Filter wide open means regeneration wide open. And of course, yeah, see you later, Jim. And of course, you can filter everything. At which point it makes sense that there is a slight roll-off. So here's your space ambient, running an entirely separate track into it. And although it's a fairly substantial loud track, it's behaving itself fairly well, even though it's not intended to be run into a giant reverb. At no point did I actually plan to turn this into a space ambient track. I'm just throwing it at it. It's meant to. The whole idea of doing stuff like this, firstly Galactic and now K-Cosmos, is to be able to do this completely deep space vibe. And we can go bright. Should be possible to play this on the recording. The original idea behind my K reverbs were that they would have no controls and just be a constant sound, because at least in macOS, they like defining constant things with a lowercase k in front of the variable. That's not necessarily anything beyond macOS, but it just ended up being a habit of mine. So some of my reverbs start with K. They're typically the ones with 5x5 matrices. Here's a thundery one. More filter, I think. implement the early reflections, which will not be filtered. And that will provide a little more focus onto what's originally happening in the sound, and probably load up my poor computer much harder than it even already is. Because this tiny laptop, a MacBook Pro from the days of Snow Leopard, not really designed for running modern plugins. I just develop all my stuff on it. I'm liking these textures though. I think this one's going to be usable for stuff, including playing it live, including throwing stuff into it and making stuff happen and playing it live. I picture like plugging a Strat into it or something, and then just make sound making. Possibly notes, swells, chords, things like that, but also just noises. Just doing the giantest reverb ever. Because DRes is engaged. See, here's your pitch down. And here's your not pitch down. Sort of the full brightness version. Bring the highs up, and then just pull the filter off of full on for just a moment. The brightest of brightness backs off, and then I can start bringing it back. Quite subtly. As soon as you start filtering, it kicks that in. Or you can move it more aggressively to really step on things. It is, after all, a steep brick wall filter, which is an FIR. So you can go from fairly heavily filtered, just a dark, vibey, spooky place, to highs. And if you cut it to 0 very abruptly, the new sound coming in is filtered with the FIR, but the brightness that's sitting inside the reverb doing infinite regeneration gradually falls back, kind of like this. Stuff like that. So yeah, the thing I'm wondering about now is how conveniently, I think I can close my stream audio window over here. I'm very close to being done for the day. Pretty happy with how well this went. Whole bunches of it were much more of a pain than I wanted or expected, but you know, Calbless, if he can fix your place, he can fix mine. And vice versa. Until that day, we will all hang out being as good as we can. So this is cool. I'm glad that this transitions so subtly. I haven't decided what the next plugin is. There are a number of possibilities, and it's not going to be this one because I'm not going to have this one ready in time. Well, it's only Tuesday. In theory, I could. It would have to go really well. I have done a bunch of work on it though, like so what I would need to do would be to come out with different concepts for these things. And do a whole mess of fuzzy details. Which is not to say it's impossible. Oh, I have an idea. So here's something I could do. Let's open up Text Wrangler. I have a bunch of changes to make here to make this work, but it's all within this space, from the end one up to and including all these feedback things, all the way over to this beginning part, but no earlier than that. But also, I think, no later. Okay, let's take it all the way to here. Copy and paste. I'll save a copy. See, if I do this, and then I can identify all the bits that need to be changed into the early reflections version. And use that. And let's just say F for wet. I'm happy I'm keeping the number of controls down. The fact that it was possible to make that work. So everything else here has to do with the big reverb, but there will be early reflections in there as well. In fact, they could be under parameter E. Hey, that works. And all the rest of this, let's start making this be more relevant. 1, 1, 1, pre-delay 0. Early reflections chord start at 0, I don't know. And then wetness of 1, and we'll just go full on giant space needle. And so we'll do something like that. And I do not know if there is a site like Shader Toy for sound. That's the thing, is like people play with shaders and get real creative, but I don't always find they do the same thing with audio. People tend to want to make stuff that looks like a Neve. You know what I mean? Which I find discouraging, but I mean, that's just me. So I don't believe I can do if I try to convert everything to the other form. With a search and replace, all that'll happen is I'll be trying to convert lowercase a to lowercase e, and then these other controls will say feedback or whatever. Although honestly, they won't even need to, because they won't have that in there. Because they won't have this, will they? We're going to try to set up just only early reflections. I've got the other stuff saved. In fact, I'm going to save this to my desktop just to be sure. There's the guts of my K-Cosmos before I change it and make it only be early reflections. Let's also throw in our get parameter E. That way at least we can do something with it, and then I put the other code right back in. And where are we at? So the pre-delay, that's going to be part of this. Bez sample, that's going to be part of this. Some of the stuff in here is going to be something else. Namely, at the point that we get into this, we have to start using the early reflection. And the rest of that stays alone, stays where it is. So early reflection L and R goes here. Rather than Bez sample. This is the output of the early reflection stage. Meaning it's going to be a certain amount of latency no matter what. But I think that will end up being fine. Right now we're going to see whether we can produce in the last, 10 minutes. I shouldn't stretch out too late. That would be ungood. But everything else ends up being exactly the same, except for it's being fed by the product of what we're doing now. So we'll quickly save that. This part is part of ooh, hi. I see something else. Early reflections applies to the FIR filter. So wherever it says that Bez stuff, I gotta stick it in here, but the pre-delay applies to all. So I'll leave that out, but then this stuff needs to get updated. That's the stuff that's getting rebuilt. There that is. And same here. That stuff works on what we've already passed in. That filtery stuff that we've got there. Now where's here? And same thing here. Cautiously and measuredly. Because all this is not happening on the raw input signal coming in. It is happening on the first pass through, which we hear directly if we have it turned up so that we can hear that part. But otherwise, this is what happens to the second pass of echoes and reverbs. Oh, and feedback sum needs to be modulated using this as well. So there we go. And let's save that. And now this doesn't refer to Bez anywhere at all. This is designed to only work with what we're producing out of the other one. So I'll save that and then maybe leave this alone for a while. All of this stays, but these increment parts don't get changed. They are the same. But all of our out is going to be changed as well. So let's see whether I can make this happen. I'm on about like 6 minutes or so. Assuming I can keep the focus. I'll try. We'll find out. So let's see. First of all, Pre-delay is not using that. Filter is not being applied to this, so I'll get it back from that other file. Hang on. Oh, and I started working with this already. So let's see, what are we looking at here? Trying to keep the focus, and hopefully this doesn't entirely break at the last moment and force me to fix it again. Feedback sum, not using you. You'll be found elsewhere. All that stuff stays the same and is found elsewhere. So that can go away. And this stuff is going to be used directly, because the regen stuff is applied to the early reflections that we are currently in the process of trying to generate through a fairly simple process of changes. This stage doesn't use feedback. This stage doesn't use regen. I can just delete all these bits. They'll be fine. Nothing's going to happen to them. I've got them elsewhere. I've got them in this, which I will save once more. Don't need to save this because it's here. I will just need to put it in the right place, and I'll worry about that later. This stuff gets updated how often do I run into the words out? Because in this stuff, out is the output of the real regenerating, feedbacking reverb. This is all about something else. Well, I got count, but count is not the same word as out. That stuff should still work. So the tokens OUT, I could change it to EAR. Then we have a whole bank of new sounds and new things, all of which will be kept exactly the same. And let's just see whether that's something that can be done. Oh, but I won't be using this feedback. But I've got it down here. And that's everything we need. Find OUT, replace with. Let's not fully capitalize it, that's bad. I could call it early. I think that doesn't clash with anything, does it? We'll call it early, we'll hold down, we'll replace everything in selection. The counts don't have to change, but I can leave them there. This is correctly doing it. I need to change all these A's to E's, but that's fairly easy to find. Same with those, nothing else has to change. Same with those, nothing else has to change. Same with those. I get to leave out feedback because we're not using it. Boop. And then I'm just going to make it a little bit more complicated. That way we can still hear the output because the output still gets to be input sample. But it will be replaced by the other thing. And Bez should be fine. It will eventually end up coming from the input sample of the overall thing. But then what we really do with it is, after having done the regeneration, I forget what I called that, so I'm going to go and look it up later. Yeah, has to be that. Okay, so that would work, except for I'm now going to go and look up what it really is. Early, was it? No, it's early loudness. And we'll set it to 0 because we're not going to need it, but if we use it, all that's going to happen is we're going to add an extra boost. And we build. Does it work? Build succeeded. 9 warnings. Hey. Now we're doing exactly the same thing that we did before, but now we're doing it all in early reflections. Meaning none of our feedback works, none of any of that stuff works. So now if we run it, KCosmos does this. A bunch of nothing. Okay, interesting. Well, it'd be cool if it made a noise, but we're probably fairly close to it making a noise. I've overlooked something, that's all. So we'll close out of here. Oh, no, wait, hang on. Could it be that I have this wrong? No. No, I've overlooked something, although it built without crashing at least. So that equals early reflection. This is all correct. The rest of this stuff hasn't been changed. Dry sample is fine. So it's got something to do with, and I haven't changed any of the stuff in the input, it's just not using everything. It's not using regen. It's not using feedback sum. Not using apply average because I've deleted that bit. Bez cycle, I think I know what's going on here. I think. Maybe I do, maybe I don't. Okay, this should be feeding in the sample. That's what it should be doing. I don't need to do anything with prev. Oh, have I? I've not remembered to change. I didn't remember to change everything from E to A. That's pretty straightforward, though. That's simple. We just never used any of this stuff. There's one bank, and I just charge through and continue to do the other ones because these are not the ones I wanted to use. I wanted to use the early reflections And we are going to use the early reflections. It's just not looking for them. But we will see whether that's good enough. Basically feeding it into an entirely separate bank, because it is. I thought I would do it all with a search and replace, but not so much. Okay, now let's see what you do. I am also curious to find out whether the poor computer falls over when I double the amount of arrays in it. Although it's got all the arrays allocated, it's just not using them. And I get to save. It's not quite the same as running 2 layers of this. So what do we got? Still silence. That only means the plugin is working. Oh, I see. Looky here. There's even more. I have forgotten to do some of these. Okay, so I'm changing arrays from A to E. I did that there. I haven't done it here. I've got another layer. And I have to do it manually because I can't just do a search and replace when it's going to change other stuff around too. But here's the final level. These A arrays are silent. There's nothing in them. That's why they were doing what they were doing, which is nothing. They're working on silence. But now that I see where they go, and all the other stuff is updated, we are basically replacing everything, after which I'll get to bring all that other stuff right back in, do about twice as many variables and things, but if it can do it, it'll run an entirely separate set of 5x5 householder matrices. Oops. The E's will be for the early reflections. The A's will be for the main reverb. The E's will feed the A's. And then you bring the E's in on a separate slider for if you want that slightly shimmery, you'd have a certain amount of pre-delay in, which will apply to both. And I think that was the last of them. Let's see if we finally got something. Now that I have changed all of the array accesses from the ones to the others. Probably it's going to work this time. Absolutely. So regen does nothing. This is only an early reflection. Derez, however, you can have a derezed early reflection. Filter does nothing. Pre-delay does do something. And here is, I've actually doubled the volume of it by mistake because I have it on early R. See, this is more the normal volume. It's doubled. So here's what the early reflections sound like. And you can do a pre-delay on the whole thing. And you won't have to have as much of the loudness of this. It can just serve as its own little pre-delay. But it serves as a bright front to the wave that becomes the big, deep, reverby wave. And again, you can darken it up with DRes if you want. And on the guitar, it adds a sort of little focus on front of everything. And we feed that into the actual delay, into the actual reverb, through the filter. And then the filter and also the regeneration loss applies only to the actual reverb, but not to the pre-delay. So looking good. Now in theory, I can just paste in what I have over here and it will work. In theory, assuming I can run 2 of these at once, and I don't have to run literally 2 of them at once, because the thing is, it isn't incrementing all of running 2 entire sets of 5x5 matrices on the same parameters. So things like updating the counters are only happening once each time. And we've got all of the space allocated. So in theory, there's our pre-delay. Here's the feedback and the regen. Oh, let's not go too far. We go too far. The end result of early reflections and feedback up to count. So this we'll put that there. We'll put that there. And then we completely blank this. After count, we start filling in this. Early, then out. There's our 1 marker. Copy that. We put that in before where it says count FL. And then we delete all of this. And where it says double early, double out. Cut. We'll put in the earlies first. Space them out like that. There's the earlies, and there is the main line to put in front of count. Then we delete all of the count. Early and then out. And we are cranking along pretty good. It would amuse me to have this completely finished by the end of the day, even though I'm running. I always run late when I do these. Whatever. what's really important. Well, tacos are important, but I will give myself time to eat my tacos. Be sure of that. Earlies in front of the counts. And cut that in front of count PL. And then we delete all of these again. So we are defining lots of extra variables, but compared to the number of variables in our arrays, this is not actually that large a number of extra variables. Out, heading down to this 4. First earlies, then outs, then the main ones. This should all be running in parallel. Except for we don't have to do all of the counts or any of these logic statements twice. They should work in parallel just as well as the rest of it. And let's see. Cut. And in front of count UL, paste this in first the earlies and then the main line. And then we delete all of this. And we're almost down to the end. Out. Cut in front of the 5. Early, then out. Here's where we start getting stuff kind of interesting. So we're going to want to take earlies out of that. But we're about to replace where it says input sample. So I will make it simple for myself and do that, and then plunk this in after here. So here's where we place our feedback, and here's where we generate our input samples. We've generated our early reflections. This is still correct. We assign our input sample equals this, and then we add the early reflection to it. And then we quit without saving in case we need to get that back from later or something. And then we see if it builds. Build. And it builds. And we put it in here, and we see if it loads, because maybe it doesn't load, because maybe it's too big in this poor little computer, even though it could run this at 192K, so in theory, it should be able to do it. And then we find out. The reflections at silence. When it says silence, the rest of this stuff blanked out. Does it in fact run? Yes. Here's that. So, is early reflections doing anything, or are we not hearing it? Let's filter. Yeah, I'm hearing it. Early reflections are that high frequency stuff. It works! Give my creation life! It just sounds dumb with no regen. And it's rather loud. What does this sound like? Kind of cool. Rather impressive. Let's just throw on the drums and play with them for a moment, and then I'm going to go and have my tacos. So I can make the regen. Oh, let's throw a little more pre-delay on. Now it's currently all dark. See, early reflections is just giving this little bright front onto the sound, but it's basically following all the same rules. It's a little weird. Let's pre-delay all the way down. So no early reflections. Let's also shorten this a little bit. I don't feel like having those noises. Here we go. So here's our dry. Here's our big space. And then if we crank up early reflections without any pre-delay, so there's like a sweet spot in there for having it sound convincing. Probably around 0.5. And we can exaggerate things so that we can hear it more clearly. So you can kind of hear the early reflections coming through, and then it transitions to the dark stuff. Then if we have full bright but not ultimate reverb, we're getting a certain kind of brightness, which may be a tiny bit of pre-delay. Wait. So it's still on the bright end of things. With no early reflections. It's got this sort of, it's too large of a space to not have any regen. So basically what we can do is literally 2 levels of regen. This is the second layer, and this is the first layer. And if the first layer is too loud, which it might just be, we can default it to something a little more chill. And with a little bit of work, we can get into a zone that is weirdly persuasive as far as sounding like a giant, ginormous space, which is, of course, the hope. Just started with 0.5s. Pretty aggressive, but what do you want for a crazy space ambient thing that we are not throwing space ambient noises at? It does make me wonder whether it could use an input or output pad, because it's a little bit aggressive. Yeah, I like having those starting at 0.5. 0.50. Actually, you know a way that I can fix that? This is a wetness, but it could be a dry wet. How about you hush for a moment and I solve this? One, 0. There's a nice little basic start setting. And now I go over to here. And if this is just simply not a wetness but a dry wet, went away too quick. The difference between these two settings, wetness and dry wet, is wetness is the one where you get to have full reverb on top of full dry. That's not going to be appropriate for this. It gets too loud. Boom. And now what we have to do is zoop down to the bottom, because it's going to make reference to dry. And replace this with how I normally write it, which I didn't honestly expect to like that. One more, semicolon. And that, because this is not a don't affect other balances type of verb, this is kind of a full-on monster and must be respected as such. What? Oh, I don't need a times equals there. That doesn't make any sense at all. I don't know why I typed that. Because I'm tired, because it's the end of a long, long day. There. That makes a little more sense. We can now build just fine. I think I can probably close it down, but I do need to shut that off. And then fire it back up. I mean, gosh, if you desperately needed this coming weekend, I don't know whether that might just be possible. Would that be fun? Keep dropping crazy new things. And right back to what I had before. Going to get rid of the rest of those. But this time, dry wet attenuates wet because it's a 50-50, so it doesn't go insane. So you can start with that anyhow. And then we can get into the wild and crazy. And use this to hear the early stuff if we want in a slightly blurred way. Or pad it. And there we're entering in stuff that was never actually meant to be run into a space ambient. Like this. And it acts pretty good. Right on. I'm done. We got there. Just a little bit of cleanup, and then that is ready to go. Although, granted, I can run it on the antique Intel-based laptop running Snow Leopard, but there's still more in there than any of my other reverbs have ever had. in the sense of all those arrays, all those layers, this could well end up being the guts of a variety of interesting reverbs. But it's going to be a little bit more heavyweight than the previous stuff I've made, so there's still the possibility of it becoming tiring for computers to run. But the poor little Intel laptop running Snow Leopard is fine. It doesn't seem to have exploded or blown up or nothing like that, so all good. And with that, I'm going to go off and have tacos, and I'll talk to you later. Bye-bye.